resolution B module resolve export. E. See if resolution is either null or ambiguous. Throw a syntax error exception. D. Assert resolution is a resolve. Let imported module be get imported module. Module. In B if in is namespace object. Then I let namespace be get module namespace. Imported module 2.
I gotta like mess with the stream settings. That's great.
env initialize binding. In namespace C else 90 ECMA International 2024 I2. Let resolution be imported module resolve export. In if resolution is either null or ambiguous, throw a syntax error exception. 3. If resolution is namespace, then let namespace be get module namespace. Resolution perform env create immutable binding. In true perform env initialize binding. In namespace I've else perform env create import binding. In resolution
Almost done messing with the stream settings.
Context. Set the function of module context to null. 0. Assert module is not undefined. 1. Set the realm of module context. Set the script or module of module context to module. 3. Set the variable environment of module context to module. 4. Set the lexical environment of module context to module. 5. Set the private environment of module context to null. 6. Set module to module context. 7. Push module context onto the execution context stack. Module is now the running execution context. 8. Code module. 9. Let var declarations the var scope declarations of code. 0. Let declared var names be a new empty list. 1. For each element d of var declarations, do a for each element dn of the bound name.
Done.
Not contain dn, then perform env create mutable binding. dn false perform env initialize.
But not done with however many left of these to replace.
The lexically scope declaration. Do if this constant declaration of d is true, then perform env create immutable binding. dn true 2. Else perform env create mutable binding. dn false 3. If d is either a function declaration, a generator declaration, an async function declaration, or an async generator declaration, then let fo be instantiate function object of d with arguments env and private env. Perform env initialize binding. dn fo 5. Remove module context from the execute context stack. 6. Return unused. 6. 2. 1. 6. 5. Execute module capability. The execute module concrete method of a source text module record module takes optional argument capability, a promise capability record, and returns either a normal completion containing unused or a throw completion. It performs the following steps when called. Let module context be a new ECMAScript code execution context. Set the function of module context to null. Set the realm of module context to module. Set the script or module of module context to module. Assert module has been linked and declarations in its module environment have been instantiated. Set the variable environment of module context to module. Set the lexical environment of module context to module. Suspend the running execution context. If a module is false, then A. Assert capability is not present. B. Push module context onto the execution context stack. Module context is now the running execution context. C. Let result be completion. Evaluation of module. ECMA International 2024 391. D. Suspend module context and remove it from the execution context stack. E. Resume the context that is now on the top of the execution context stack as the running execution context. F. If result is an abrupt completion, then I return result 10. Else, A. Assert capability is a promise capability record. B. Perform a sync block start capability module module context 1. Return unused 6, 2, 1, 7. Get imported module referrer specifier. The abstract operation get imported module takes arguments referrer, a cyclic module record, and specifier, a string, and returns a module record. It performs the following steps when called. Assert. Exactly one element of referrer is a record whose is specifier. Since load requested modules has completed successfully on referrer prior to invoking this abstract operation, let record be the record in referrer whose is specifier. Return record 6, 2, 1, 8. Host load imported module referrer specifier host defined payload. The host defined abstract operation host load imported module takes arguments referrer, a script record, a cyclic module record, or a realm record, specifier, a string, host defined anything, and payload, a graph loading state record or a promise capability record, and returns unused. Note an example of when referrer can be a realm record is in a web browser host. There, if a user clicks on a control given by button type equals button on click equals import foo mjs click me button, there will be no active script or module at the time the import expression runs. More generally, this can happen in any situation where the host pushes execution contexts with null script or module components onto the execution context stack. An implementation of hostile ode imported module must conform to the following requirements. The host environment must perform finished loading imported module referrer specifier payload result, where result is either a normal completion containing the loaded module record or a throw completion, either synchronously or asynchronously. If this operation is called multiple times with the same referrer specifier parent, it performs finished loading imported module referrer specifier payload result, where result is a normal completion. Then it must perform finished loading imported module referrer specifier payload result with the same result each time. The operation must treat payload as an opaque value to be passed through to finished loading imported module. The actual process performed is host defined, but typically consists of performing whatever I/O operations are necessary to load the appropriate module record. Multiple different referrer specifier pairs may map to the same module record instance. The actual mapping semantics is host-defined, but typically a normalization process is applied to specifier as part of the mapping process. A typical normalization process would include actions such as expansion of relative and abbreviated path specifiers. 92. Copyright sign. ECMA International 2024. 16.2.1.9. Finished loading imported module referrer specifier payload result. The abstract operation finished loading imported module takes arguments referrer, a script record, a cyclic module record, or a realm record, specifier, a string, payload, a graph loading state record or a promise capability record, and result. Either a normal completion containing a module record or a throw completion, and returns unused. It performs the following steps when called. If result is a normal completion, then if referrer contains a record whose is specifier, then I assert that records is result be else I append the record specifier result to referrer. If payload is a graph loading state record, then I perform continue module loading payload result, else I perform continue dynamic import payload result. Return unused. 6.2.1.10. Get module namespace module. The abstract operation get module namespace takes argument module, an instance of a concrete subclass of module record, and returns a module namespace object or empty. It retrieves the module namespace object representing modules exports, lazily creating it the first time it was requested, and storing that in module for future retrieval. It performs the following steps when called. Assert. If module is a cyclic module record, then module is not new or unlinked. Let namespace be module. If namespace is empty, then a let exported names be module. Get exported names be. Let unambiguous names be a new empty list. See for each element name of exported names. Do il at resolution be module resolve export name 2. If resolution is a resolved binding record, Append name to unambiguous names. D set namespace to module namespace create. Module. Unambiguous names. Return namespace. 6, 2, 1, 1, 1 runtime semantics. Evaluation module. Empty. Return undefined. Module body. Module item list. Let result be completion. Evaluation of module item list. If result is a normal completion and result is empty, then a return undefined 3. Return result. Module item list. Module item list. Module item. Let SL be. Evaluation of module item list. Let S be completion. Evaluation of module item. Return. Update empty. S. SL. Note get module namespace never throws. Instead, unresolvable names are simply excluded from the namespace at this point. They will lead to a real linking error later unless they are all ambiguous star exports that are not explicitly requested anywhere. ECMA International 2024 393. Note the value of a module item list is the value of the last value producing item in the module item list. Module item. Import declaration. Return empty 16. 2. Import syntax. Import declaration. Import clause from clause. Import module specifier. Import clause. Imported default binding. Namespace import. Named imports. Imported default binding. Namespace import. Imported default binding. Named imports. Imported default binding. Imported binding. Namespace import. As imported binding. Named imports. Imports list. Imports list. From clause. From module specifier. Imports list. Import specifier. Imports list. Import specifier. Import specifier. Imported binding. Module export name as imported binding module specifier. String literal imported binding. Binding identifier. Yield. Class await. 16. 2. 1 static semantics. Early errors. Module item. Import declaration. It is a syntax error if the bound names of import declaration contains any duplicate entries. 94. Copyright sign. ECMA International 2024 16. 2 static semantics. Import entries. The syntax-directed operation import entries takes no arguments and returns a list of import entry records. It is defined piecewise over the following productions. Module. Empty. Return a new empty list. Module item list. Module item list. Module item. Let entries 1 be import entries of module item list. Let entries 2 be import entries of module item. Return the list concatenation of entries 1 and entries 2. Module item. Export declaration. Statement list item. Return a new empty list. Import declaration. Import clause from clause. Let module be the sole element of module requests of from clause. Return import entries for module of import clause with argument module. Import declaration. Import module specifier. 1. Return a new empty list. 6. 2. 3 static semantics. Import entries for module. The syntax-directed operation import entries for module takes argument module, a string, and returns a list of import entry records. It is defined piecewise over the following PR adductions. Import clause. Imported default binding. Namespace import. Let entries 1 be import entries for module of imported default binding with argument module. Let entries 2 be import entries for module of namespace import with argument module. Return the list concatenation of entries 1 and entries 2. Import clause. Imported default binding. Named imports. Let entries 1 be import entries for module of imported default binding with argument module. Let entries 2 be import entries for module of named imports with argument module. Return the list concatenation of entries 1 and entries 2. Imported default binding. Imported binding. Let local name be the sole element of bound names of imported binding. Let default entry be the import entry record. Module. Default. Local name. Local name. Return default entry. Namespace import. As imported binding. Let local name be the string value of imported binding. Let entry be the import entry record. Module. Namespace object. Local name. Local name. Return entry. ECMA International 2024 395. Named imports. Return a new empty list. Imports list. Imports list. Import specifier. Let specs 1 be the import entries for module of imports list with argument module. Let specs 2 be the import entries for module of import specifier with argument module. Return the list concatenation of specs 1 and specs 2. Import specifier. Imported binding. Let local name be the sole element of bound names of imported binding. Let entry be the import entry record. Module. Local name. Local name. Local name. Return entry. Import specifier. Module export name as imported binding. Let import name be the string value of module export name. Let local name be the string value of imported binding. Let entry be the import entry record. Module. Import name. Local name. Local name. Return entry. 6. 2. 3. Export syntax. Export declaration. Export from clause. Export named exports. Export variable statement. Yield plus await. Export declaration. Yield plus await. Export default hoistable declaration. Yield plus await plus default. Export default class declaration. Yield plus await plus default. Export default. Look ahead. Function. Async. No line terminator here. Function. Class. Assignment expression. Plus in. Yield. Plus await. Export from clause as module export name named exports. Named exports. Exports list. Exports list. Exports list. Export specifier. Exports list. Export specifier. Export specifier. Module export name. 96. ECMA International 2024. Module export name as module export name. 16. 2. 3. 1 static semantics. Early errors. Export declaration. Export named exports. It is a syntax error if reference bindings of named exports contains any string literals. For each identifier name n in referenced bindings of n, aimed exports. It is a syntax error if string value of n is a reserved word or the string value of n is one of implements. Interface. Let. Package. Private. Protected. Public. Or static. 6. 2. 3. 2 static semantics. Exported bindings. The syntax-directed operation exported bindings takes no arguments and returns a list of strings. It is defined piecewise over the following productions. Module item list. Module item list. Module item. Let names 1 be exported bindings of module item list. Let names 2 be exported bindings of module item. Return the list concatenation of names 1 and names 2. Module item. Import declaration. Statement list item. Return a new empty list. Export declaration. Export from clause. 1. Return a new empty list. Export declaration. Export named exports. Return the exported bindings of named exports. Export declaration. Export variable statement 1. Return the bound names of variable statement. Export declaration. Export declaration 1. Return the bound names of declaration. Export declaration. Export default hoistable declaration. Export default class declaration. Export default assignment expression. Return the bound names of this export declaration. Note the above rule means that each reference bindings of named exports is treated as an identifier reference. Note exported bindings are the locally bound names that are explicitly associated with the module's exported names. ECMA International 2024 397. Named exports. Return a new empty list. Exports list. Exports list. Export specifier. Let names 1 be the exported bindings of exports list. Let names 2 be the exported bindings of export specifier. Return the list concatenation of names 1 and names 2. Export specifier. Module export name. Return a list whose sole element is the string value of module export name. Export specifier. Module export name as module export name. Return a list whose sole element is the string value of the first module export name. 6. 2. 3. 3 static semantics. Exported names. The syntax-directed operation exported names takes no arguments and returns a list of strings. It is defined piecewise over the following productions. Module item list. Module item list. Module item. Let names 1 be exported names of module item list. Let names 2 be exported names of module item. Return the list concatenation of names 1 and names 2. Module item. Export declaration. Return the exported names of export declaration. Module item. Import declaration. Statement list item. Return a new empty list. Export declaration. Export from clause. Return the exported names of export from clause. Export from clause. Return a new empty list. Export from clause. As module export name. Return a list whose sole element is the string value of module export name. Export from clause. Named exports. Return the exported names of named exports. 398. ECMA International 2024. export declaration, export variable statement 1. Return the bound names of variable statement, export declaration, export declaration 1. Return the bound names of declaration, export declaration, export default hoistable declaration, export default class declaration, export default assignment expression, return default. Named exports, return a new empty list, exports list, exports list, export specifier. Let names 1 be the exported names of exports list. Let names 2 be the exported names of export specifier. Return the list concatenation of names 1 and names 2. Export specifier. Module export name. Return a list whose sole element is the string value of module export name. Export specifier. Module export name as module export name. Return a list whose sole element is the string value of the second module export name. 6, 2, 3, 4 static semantics. Export entries. The syntax-directed operation export entries takes no arguments and returns a list of export entry records. It is defined piecewise over the following productions. Module. Empty. Return a new empty list. Module item list. Module item list module item. Let entries 1 be export entries of module item list. Let entries 2 be export entries of module item. Return the list concatenation of entries 1 and entries 2. Module item. Import declaration. Statement list item. Return a new empty list. Export declaration. Export from clause. Let module be the sole element of module requests of from clause. Return export entries for module of export from clause with argument module. ECMA International 2024 399. Export declaration. Export named exports. Return export entries for module of named exports with argument null. Export declaration. Export variable statement. Let entries be a new empty list. Let names be the bound names of variable statement. For each element name of names, do a append the export entry record. Null. Name. To entries. Return entries. Export declaration. Export declaration. Let entries be a new empty list. Let names be the bound names of declaration. For each element name of names, do a append the export entry record. Null. Name. To entries. Return entries. Export declaration. Export default hoistable declaration. Let names be bound names of hoistable declaration. Let local name be the sole element of names. Return a list whose sole element is a new export entry record. Null. Local name. Default. Export declaration. Export default class declaration. Let names be bound names of class declaration. Let local name be the sole element of names. Return a list whose sole element is a new export entry record. Null. Local nar. Me. Default. Export declaration. Export default assignment expression. Let entry be the export entry record. Null. Default. Return entry. 6, 2, 3, 5 static semantics. Export entries for module. The syntax-directed operation export entries for module takes argument module, a string or null, and returns a list of export entry records. It is defined piecewise over the following productions. Export from clause. 1, 2. Let entry be the export entry record. Module. All but default. Null. Return entry. 00. ECMA International 2024. Note default is used within this specification as a synthetic name for anonymous default export values. See this note for more details. Export from clause. As module export name. Let export name be the string value of module export name. Let entry be the export entry record. Module. All. Null. Export name. Return entry. Named exports. Return a new empty list. Exports list. Export specifier. Let specs 1 be the export entries for module of exports list with argument module. Let specs 2 be the export entries for module of export specifier with argument module. Return the list concatenation of specs 1 and specs 2. Export specifier. Module export name. Let source name be the string value of module export name. If a module is null, then a let local name be source name. B let import name be null. Else a let local name be null. B let import name be source name. Return a list whose sole element is a new export entry record. Module. Import name. Local name. Source name. Export specifier. Module export name as module export name. Let source name be the string value of the first module export name. Let export name be the string value of the second module export name. If a module is null, then a let local name be source name. B let import name be null. Else a let local name be null. B let import name be source name. Return a list whose sole element is a new export entry record. Module import name, local name, export name. 6, 2, 3, 6 static semantics. Referenced bindings. The syntax-directed operation referenced bindings takes no arguments and returns a list of parse nodes. It is defined piecewise over the following productions. Named exports. Return a new empty list. Exports list. Exports list. Exports specifier. Let names 1 be the referenced bindings of exports list. Let names 2 be the referenced bindings of export specifier. Return the list concatenation of names 1 and names 2. Export specifier. Module export name as module export name. Return the referenced bindings of the fee. RST module export name. ECMA International 2024 401. Module export name. Identifier name. Return a list whose sole element is the identifier name. Module export name. String literal. Return a list whose sole element is the string literal. 6, 2, 3, 7 runtime semantics. Evaluation. Export declaration. Export from clause. Export named exports. Return empty. Export declaration. Export variable statement. Return. Evaluation of variable statement. Export declaration. Return. Evaluation of declaration. Export default hoistable declaration. Return. Evaluation of hoistable declaration. Export default class declaration. Let value be capital B I N D I N G capital C L A S S capital D E C L A R A T I O N capital E V A L U A T of class declaration. Let class name be the sole element of bound names of class declaration. If class name is default, then let env be the running execution context's lexical environment. B perform. Initialize bound name, default, value, env, return empty, export declaration, export default assignment expression. If is anonymous function definition, assignment expression, is true, then let value be named evaluation of assignment expression with argument default. Else let RHS be evaluation of assignment expression. B let value be get value. RHS. Let env be the running execution context's lexical environment. Perform. Initialize bound name, default, value, env, return empty. 7 error handling and language extensions. An implementation must report most errors at the time the relevant ECMAScript language construct is evaluated. An early error is an error that can be detected and reported prior to the evaluation of any construct in the script containing the error. The presence of an early error prevents the evaluation of the construct. An implementation must report early errors in a script as part of parsing that script in ParseScript. Early errors in a module are reported at the point when the module would be evaluated and the module is never initialized. Early errors in 02, copyright sign, ECMA International 2024, eval code are reported at the time eval is called and prevent evaluation of the eval code. All errors that are not early errors are runtime errors. An implementation must report as an early error any occurrence of a condition that is listed in a static semantics, early errors subclause of this specification. An implementation shall not treat other kinds of errors as early errors even if the compiler can prove that a construct cannot execute without error under any circumstances. An implementation may issue an early warning in such a case, but it should not report the error until the relevant construct is actually executed. An implementation shall report all errors as specified, except for the following. Except as restricted in 17.1, a host or implementation may extend script syntax, module syntax, and regular expression pattern or flag syntax. To permit this, all operations, such as calling eval, using a regular expression literal, or using the function or regexp constructor that are allowed to throw syntax error permitted to exhibit host defined behavior instead of throwing syntax error when they encounter a host-defined extension to the script syntax or regular expression pattern or flag syntax. Except as restricted in 17.1, a host or implementation may provide additional types, values, objects, properties, and functions beyond those described in this specification. This may cause constructs, such as looking up a variable in the global scope, to have host-defined behavior instead of throwing an error, such as reference error. 7.1 Forbidden extensions. An implementation must not extend this specification in the following ways. ECMAScript function objects defined using syntactic constructors in strict mode code must not be created with own properties named caller or arguments. Such own properties also must not be created for function objects defined using an arrow function, method definition, generator declaration, generator expression, async generator declaration, async generator expression, class declaration, class expression, async function declaration, async function expression, or async arrow function regardless of whether the definition is contained in strict mode code. Built-in functions. Strict functions created using the function constructor. Generator functions created using the generator constructor. Async functions created using the async function constructor. And functions created using the bind method also must not be created with such own properties. If an implementation extends any function object with a known property named caller, the value of that property, as observed using, must not be a strict function object. If it is an accessor property, the function that is the value of the properties. Neither mapped nor unmapped arguments objects may be created with a known property named caller. The behavior of built-in methods which are specified in ECMA 402, such as those named to locale string, must not be extended except as specified in ECMA 402. The regexp pattern grammars in 2.2, 2.1 and b 1.2 must not be extended to recognize any of the source characters at Z or raise Z as identity escape. Class Unicode mode. When the Unicode mode grammar parameter is present, the syntactic grammar must not be extended in any manner that allows the token to immediately follow source text that is matched by the binding identifier non-terminal symbol. When processing strict mode code, an implementation must not relax the early error rules of 1.2, 9, 3, 1. Template escape sequence must not be extended to include legacy octal escape sequence or non-octal decimal escape sequence as defined in 1.2, 9, 4. When processing strict mode code, the extensions defined in B 3.1, B 3.2, B 3.3, and B 3.5 must not be supported. When parsing for the module goal symbol, the lexical grammar extensions defined in B 1.1 must not be supported. Import call must not be extended. ECMA International 2024 403. 18 ECMAScript standard built-in objects. There are certain built-in objects available whenever an ECMAScript script or module begins execution. 1. The global object is part of the global environment of the executing program. Others are accessible as initial properties of the global object or indirectly as properties of accessible built-in objects. Unless specified otherwise, a built-in object that is callable as a function is a built-in function object with the characteristics described in 10.3. Unless specified otherwise, the internal slot of a built-in object initially has the value true. Every built-in function object has an internal slot whose value is the realm record of the realm for which the object was initially created. Many built-in objects are functions. They can be invoked with arguments. Some of them furthermore are constructors. They are functions intended for use with the new operator. For each built-in function, the specification describes the arguments required by that function and the properties of that function object. For each built-in constructor, the specification furthermore describes properties of the prototype object of that constructor and properties of specific object instances returned by a new expression that invokes that constructor. Unless otherwise specified in the description of a particular function, if a built-in function or constructor is given fewer arguments than the function is specified to require, the function or constructor shall behave exactly as if it had been given sufficient additional arguments. each such argument being the undefined value. Such missing arguments are considered to be not present and may be identified in that manner by specification algorithms. In the description of a particular function, the terms this value and new target have the meanings given in 10.3, unless otherwise specified in the description of a particular function. If a built-in function or constructor described is given more arguments than the function is specified to allow, the extra arguments are evaluated by the calling, then ignored by the function. However, an implementation may define implementation-specific behavior relating to such arguments as long as the behavior is not the throwing of a type error exception that is predicated simply on the presence of an extra argument. Unless otherwise specified, every built-in function and every built-in constructor has the function prototype object, which is the initial value of the expression function prototype, 2023, as the value of its internal slot. Unless otherwise specified, every built-in prototype object has the object prototype object, which is the initial value of the expression object prototype, E2013, as the value of its internal slot, except the object prototype object itself. If this specification defines a built-in constructor's behavior via algorithm steps, then that is its behavior for the purposes of both and. If such an algorithm needs to distinguish the two cases, it checks whether new target is undefined, which indicates an invocation. Built-in function objects that are not identified as constructors do not implement the internal method unless otherwise specified in the description of a particular function. Built-in function objects that are not constructors do not have a prototype property unless otherwise specified in the description of a particular function. Each built-in function defined in this specification is created by calling the create built-in function abstract operation 1034. The values of the length and name parameters are the initial values of the length and name properties as discussed below. The values of the prefix parameter are similarly discussed below. Every built-in function object, including constructors, has a length property whose value is a non-negative integral number. Unless otherwise specified, this value is the number of required parameters shown in the subclause heading for the function description. Optional parameters and rest parameters are not included in the parameter count. Note 1. Implementations that add additional capabilities to the set of built-in functions are encouraged to do so by adding new functions rather than adding new parameters to existing functions. 04. Copyright sign, ECMA International 2024. Note 2. For example, the function object that is the initial value of the map property of the array prototype object is described under the subclause heading array prototype map. Callback fn, this arg, which shows the two named arguments callback fn in this arg, the latter being optional. Therefore, the value of the length property of that function object is 1. Unless otherwise specified, the length property of a built-in function object has the attributes false, false, true. Every built-in function object, including constructors, has a name property whose value is a string. Unless otherwise specified, this value is the name that is given to the function in this specification. Functions that are identified as anonymous functions use the empty string as the value of the name property. For functions that are specified as properties of objects, the name value is the property name string used to access the function. Functions that are specified as get or set access of functions of built-in properties of get or set, respectively, passed to the prefix parameter when calling create built-in function. The value of the name property is explicitly specified for each built-in functions whose property key is a symbol value. If such an explicitly specified value starts with the prefix get or set in the function for which it is specified as a get or set accessor function of a built-in property, the value without the prefix is passed to the name parameter, and the value get or set, respectively, is passed to the prefix parameter when calling create built-in function. Unless otherwise specified, the name property of a built-in function object has the attributes false, false, true. Every other data property described in clauses 19 through 28 and in Annex B 2 has the attributes true, false, true unless otherwise specified. Every accessor property described in clauses 19 through 28 and in Annex B 2 has the attributes false, true unless otherwise specified. If only a getAccessor function is described, the setAccessor function is the default value, undefined. If only a setAccessor is described, the getAccessor is the default value, undefined. 9. The global object. The global object is created before control enters any execution context. Does not have an internal method. It cannot be used as a constructor with the new operator. Does not have an internal method. It cannot be invoked as a function. Has an internal slot whose value is host-defined. May have host-defined properties in addition to the properties defined in this specification. This may include a property whose value is the global object itself. 9.1 Value properties of the global object. 191. 1 Global this. The initial value of the global this property of the global object in a realm record realm is realm. This property has the attributes true, false, true. 191. 2 Infinity. The value of infinity is plus C6 1 6 1. This property has the attributes false, false, false. ECMA International 2024 405 191. 3 Nan. The value of nan is nan. C6 1 6 1. This property has the attributes false, false. Configurable. Force 191. 4 Undefined. The value of undefined is undefined. C6 1 1. This property has the attributes false, false, false. 9.2 Function properties of the global object. 9 2 1 Eval x. This function is the %eval %intrinsic object. It performs the following steps when called. Return. Perform eval x false. False 192 1 1. Perform eval x strict caller direct. The abstract operation perform eval takes arguments x, an ECMAScript language value, strict caller, a boolean, and direct a boolean, and returns either a normal completion containing an ECMAScript language value or a throw completion. It performs the following steps when called. Assert. If direct is false, then strict cal r is also false. If x is not a string, return x. Let eval realm be the current realm record. Note, in the case of a direct eval, eval realm is the realm of both the caller of eval and of the eval function itself. Perform. Host ensure can compile strings, eval realm, x, direct. Let in function be false. Let in method be false. Let in derived constructor be false. Let in class field initializer be false. 0. If direct is true, then a let this envrec be get this environment. B if this envrec is a function environment record, then I let f be the envrec. 2. Set in function to true. 3. Set in method to the envrec has super binding. 5. If f is derived, set in derived constructor to true. V let class field initializer name be f. V. If class field initializer name is not empty, set in class field initializer to true. 1. Perform the following substeps in an implementation defined order, possibly interleaving parsing and error detection. A let script be parse text, string to code points, x, script. B if script is a list of errors, throw a syntax error exception. C if script contains script body is false, return undefined. D let body be the script body of script. E if in function is false and body contains new target, throw a syntax error exception. F if in method is false and body contains super property, throw a syntax error exception. G if in derived constructor is false and body contains supercall, throw a syntax error exception. H if in class field initializer is true and contains arguments of body is true, throw a syntax error exception. 2. If strict caller is true, let strict eval be true. 3. Else, let strict eval be as strict of script. 4. Let running context be the running execution context. 06. ECMA International 2024 15. Note, if direct is true, running context will be the execution context that performed the direct eval. If direct is false, running context will be the execution context for the invocation of the eval function. 6. If direct is true, then a let lexenv be new declarative environment, running context's lexical environment. B let var_env be running context's variable environment. C let private env be running context's private environment. 7. Else, a let lexenv be new declarative environment, eval realm. B let var_env be eval realm. C let private env be null. 8. If strict eval is true, Set var env to lexenv 9. If running context is not already suspended, suspend running context. 0. Let eval context be a new ECMAScript code execution context. 1. Set eval context's function to null. 2. Set eval context's realm to eval realm. 3. Set eval context script or module to running context script or module. 4. Set eval context's variable environment to var env. 5. Set eval context's lexical environment to lexenv. 6. Set eval context's private environment to private env. 7. Push eval context onto the execution context s tag. Eval context is now the running execution context. 8. Let result be completion. Eval declaration instantiation. Body. var env. lexenv. private env. strict eval. 9. If result is a normal completion, then a set result to completion. Evaluation of body. 0. If result is a normal completion and result is empty, then a set result to normal completion. Undefined. 1. Suspend eval context and remove it from the execution context stack. 2. Resume the context that is now on the top of the execution context stack as the running execution context. 3. Return result. 9. 2. 1. To host ensure can compile strings, Corley realm, parameter strings, body string, direct. The host-defined abstract operation host ensure can compile strings takes arguments Corley realm, a realm record, parameter strings, a list of strings, body string, a string, and direct a boolean, and returns either a normal completion containing unused or a throw completion. It allows host environments to block certain ECMAScript functions which allow developers to interpret and evaluate strings as ECMAScript code. Parameter strings represents the strings that, when using one of the function constructors, will be concatenated together to build the parameters list. Body string represents the function body or the string passed to an eval call. Direct signifies whether the evaluation is a direct eval. The default implementation of host ensure can compile strings is to return normal completion, unused 1 9, 2, 1, 3. Eval declaration instantiation, body, var env, lexenv, private env, strict. The abstract operation eval declaration instantiation takes arguments body a script body parse node, var env, an environment record, lexenv, a declarative environment record, private env, a private environment record or null, and strict, a boolean, and returns either a normal completion containing unused or a throw completion. It performs the following steps when called. Let var names be the var declared names of body. Let var declarations be the var scope declarations of body. If strict is false, then note the eval code cannot instantiate variable or function bindings in the variable environment of the calling context that invoke the eval if either the code of the calling context or the eval code is strict mode code. Instead, such bindings are instantiated in a new variable environment that is only accessible to the eval code. Bindings introduced by let, const, or class declarations are always instantiated in a new lexical environment. ECMA International 2024 407. If var env is a global environment record, then I for each element name of var names. Do if var env has lexical declaration, name, is true. Throw a syntax error exception. Note, eval will not create a global var declaration that would be shadowed by a global lexical declaration. B let this env be lexenv, C assert. The following loop will terminate. D repeat. While the CNV is not var env, I if the CNV is not an object environment record. T hen. Note, the environment of with statements cannot contain any lexical declaration, so it doesn't need to be checked for var let hoisting conflicts. For each element name of var names, do if the CNV has binding name is true, then I throw a syntax error exception. 2. Note, an XB 3.4 defines alternate semantics for the above step. B note, a direct eval will not hoist var declaration over a like-named lexical declaration. 2. Set the CNV to the CNV. Let private identifiers be a new empty list. Let pointer be private CNV. Repeat. While pointer is not null, a for each private name binding of pointer. Do I if private identifiers does not contain binding, Append binding to private identifiers. B set pointer to pointer. If all private identifiers valid if body with argument private identifiers is false. Throw a syntax error exception. Let functions to initialize be a new empty list. Let declared function names be a new empty list. 0. For each element D of var declarations, in reverse list order, do if D is not either a variable declaration, a for binding, or a binding identifier. Then, I assert, D is either a function declaration, a generator declaration, an async function declaration, or an async generator declaration. 2. Note, if there are multiple function declarations for the same name, the last declaration is used. 3. Let fn be the sole element of the bound names of D. If declared function names does not contain fn, then, if var_env is a global environment record, then, let fn definable be var_env can declare global function, fn, be if fn definable is false. Throw a type error exception. Append fn to declared function names. Insert D as the first element of functions to initialize. 1. Let declared var names be a new empty list. 2. For each element D of var declarations, do if D is either a variable declaration, a for binding, or a binding identifier. Then, for each string vn of the bound names of D, do if declared function names does not contain vn, then, if var_env is a global environment record, then, I let vn definable be var_env can declare global var, vn. 2. If vn definable is false, throw a type error exception. B if declared var names does not contain vn, then, I append vn to declared var names. 3. Note, an xb, 3, 2, 3 adds additional steps at this point. 4. Note, no abnormal terminations occur after this algorithm step unless var_env is a global environment record and the global object is a proxy exotic object. 5. Let lex declarations be the lexically scoped declarations of body. 6. For each element D of lex declarations, do a note. Lexically declared names are only instantiated here but not initialized. B for each element Dn of the bound names of D, do if this constant declaration of D is true, then perform lexenv create immutable binding. Dn true. 2. Else perform lexenv create mutable binding. Dn false. 7. For each parse node f of functions to initialize, do 408. ECMA International 2024. A let fn be the sole element of the bound names of f. B let fo be instantiate function object of f with arguments lexenv and private env. C if var_env is a global environment record. Then, I perform var_env create global function binding, fn, fo, true. D else, I let binding exists be var_env has binding, fn. 2. If binding exists as false, then, note, the following invocation cannot return an abrupt completion because of the validation preceding step 14. Perform var_env create mutable binding, fn, true. Perform var_env initialize binding, fn, fo. 3. Else, perform var_env set mutable binding, fn, fo. False. 18. For each string vn of declared var names, do if var_env is a global environment record. Then, I perform var_env create global var binding, vn, true. B else, I let binding exists be var_env has binding, vn. 2. If binding exists as false, then, note, the following invocation cannot return an abrupt completion because of the validation preceding step 14. Perform var_env create mutable binding, vn, true. Perform var_env initialize binding, vn, undefined. 9. Return unused. Note an alternative version of this algorithm is described in B 3.4.9. 2. 2 is finite number. This function is the is finite intrinsic object. It performs the following steps when called. Let num be to number. If num is not finite, return false. Otherwise, return true. 9. 2. 3 is nan number. This function is the is nan intrinsic object. It performs the following steps when called. Let num be to number. If num is nan, return true. Otherwise, return false. 9. 2. 4 parse float. String. This function produces a number value dictated by interpretation of the contents of the string argument as a decimal literal. It is the %parsefloat %intrinsic object, a reliable way for ECMAScript code to test if a value x is none is an expression of the form. Note, x equals x. The result will be true if and only if x is none. ECMA International 2024 409. It performs the following steps when called. Let input string be. To string. String. Let trimmed string be. Trim string. Input string. Start. Let trimmed be string to code points. Trimmed string. Let trimmed prefix be the longest prefix of trimmed that satisfies the syntax of a str decimal literal, which might be trimmed itself. If there is no such prefix, return none. Let parsed number be parsed text. Trimmed prefix. str decimal literal. Assert. Parsed number as a parse node. Return string numeric value of parsed number. 9, 2, 5 parse int. String. Radix. This function produces an integral number dictated by interpretation of the contents of string according to the specified radix. A leading white space in string is ignored. If radix coalesces to 0, such as when it is undefined, it is assumed to be 10 except when the number representation b begins with 0x or 0x, in which case it is assumed to be 16. If radix is 16, the number representation may optionally begin with 0x or 0x. It is the %parseInt %intrinsic object. It performs the following steps when called. Let input string be. To string. String. Let s be. Trim string. Input string. Start. Let sign be 1. If s is not empty and the first code unit of s is the code unit 0 times 002d, hyphen minus, set sign to -1. If s is not empty and the first code unit of s is either the code unit 0 times 002b plus sign, or the code unit 0 times 002d, hyphen minus, set s to the substring of s from index 1. Let r be r. To int 32. Radix. Let strip prefix be true. If r0, then if r2 or r36. Return none. B if r16. Set strip prefix to false. Else set r to 10. 0. If strip prefix is true, then if the length of s is at least 2 and the first two code units of s are either 0x or 0x, then I set s to the substring of s from index 2. Set r to 16. 1. If s contains a code unit that is not a radix r digit, let n be the index within s of the first such code unit. Otherwise, let n be the length of s. 2. Let z be the substring of s from 0 to end. 3. If z is empty, return none. 4. Let mathInt be the integer value that is represented by z in radix r notation, using the letters a through z, and a through z for digits with values 10 through 35. However, if r equals 10 and z contains more than 20 significant digits, every significant digit after the 20th of may be replaced by a 0 digit, at the option of the implementation. And if r is not one of 2, 4, 8, 10, 16, or 32, then mathInt may be an implementation approximated integer representing the integer value denoted by z in radix r notation. 5. If mathInt equals 0, then if sign equals -1, return -0, b return +0. 6. Return sign mathInt. Note this function may interpret only a leading portion of string as a number value. It ignores any code units that cannot be interpreted as part of the notation of a decimal literal, and no indication is given that any such code units were ignored. 10. ECMA International 2024. Note this function may interpret only a leading portion of string as an integer value. It ignores any code units that cannot be interpreted as part of the notation of an integer, and no indication is given that any such code units were ignored. 9. 2. 6. URI handling functions. Uniform resource identifiers, or URIs, are strings that identify resources, for example web pages or files, and transport protocols by which to access them, for example HTTP or FTP, on the internet. The ECMAScript language itself does not provide any support for using URIs except for functions that encode and decode URIs as described in this section. Encode URI and decode URI are intended to work with complete URIs. They assume that any reserved characters are intended to have special meaning. For example, as delimiters, and so are not encoded. Encode URI component and decode. URI component are intended to work with the individual components of a URI. They assume that any reserved characters represent text and must be encoded to avoid special meaning when the component is part of a complete URI. 9, 2, 6, 1 decode URI, encoded URI. This function computes a new version of a URI in which each escape sequence and UTF-8 encoding of the sort that might be introduced by the encode URI function is replaced with the UTF-16 encoding of the code points that it represents. Escape sequences that could not have been introduced by encode URI are not replaced. It is the %decode URI %intrinsic object. It performs the following steps when called. Let URI string be. To string, encoded URI. Let preserve escape set be. At and equals plus $, return. Decode, URI string, preserve escape set. 9, 2, 6, 2 decode URI component, encoded URI component. This function computes a new version of a URI in which each escape sequence and UTF-8 encoding of the sort that might be introduced by the encode URI component function is replaced with the UTF-16 encoding of the code points that it represents. It is the %decode URI component %intrinsic object. It performs the following steps when called. Let component string be. To string, encoded URI component. Let preserve escape set be the empty string. Return. Decode. Component string, preserve escape set. Note 1. The set of reserved characters is based upon RFC 2396 and does not reflect changes introduced by the more recent RFC 3986. Note 2. Many implementations of ECMAScript provide additional functions and methods that manipulate web pages. These functions are beyond the scope of this standard. ECMA International 2024 411 19 6, 3 encode URI. This function computes a new version of a UTF-16 encoded 6, 1, 4 URI in which each instance of certain code points is replaced by 1, 2, 3, or 4 escape sequences representing the UTF-8 encoding of the code point. It is the %encode URI %intrinsic object. It performs the following steps when called. Let URI string be. To string, URI, let extra unescape be. At and equals plus $, return. Encode, URI string, extra unescaped. 9, 2, 6, 4 encode URI component. This function computes a new version of a UTF-16 encoded 6, 1, 4 URI in which each instance of certain code points is replaced by 1, 2, 3, or 4 escape sequences representing the UTF-8 encoding of the code point. It is the %encode URI component %intrinsic object. It performs the following steps when called. Let component string be. To string, URI component. Let extra unescape be the empty string. Return. Encode. Component string. Extra unescaped. 9, 2, 6, 5 encode. String. Extra unescaped. The abstract operation encode takes argument string, a string, and extra unescaped, a string, and returns either a normal completion containing a string or a throw completion. It performs URI encoding and escaping, interpreting string as a sequence of UTF-16 encoded code points is described in 6, 1, 4. If a character is identified as unreserved in RFC 2396 or appears in extra unescaped, it is not escaped. It performs the following steps when called. Let len be the length of string. Let r be the empty string. Let always unescaped be the string concatenation of the ASCII word characters and art. Let unescaped set be the string concatenation of always unescaped and extra unescaped. Let 0 repeat. While k, len, let c be the code unit at index k within string. B if unescaped set contains c, then I set k to k plus 1, 2. Set r to the string concatenation of r and c, c else I let cp be code point at string k 2. If cp is true, throw a URI error exception. 3. Set k to k plus cp. 5. Let octets be the list of octets resulting by applying the UTF-8 transformation to CP, v for each element octet of octets. Do return R. 2. Let hex be the string representation of octet, formatted as an uppercase hexadecimal number. Set R to the string concatenation of R, %, and string pad. hex 2 0 start 412 ECMA International 2024. Note, because percent encoding is used to represent individual octets, a single code point may be expressed as multiple consecutive escape sequences, one for each of its 8-bit UTF-8 code units. 1926 60 code string preserve escape set. The abstract operation decode takes argument string, a string, and preserve escape set, a string, and returns either a normal completion containing a string or a throw completion. It performs URI unescaping and decoding, preserving any escape sequences that correspond to basic Latin characters in preserve escape set. It performs the following steps when called. Let len be the length of string. Let r be the empty string. Let 0 repeat. While k, len abc. Let c be the code unit at index k within string. Let s be e if c is the code unit 0 times 0025 %. Then if k plus 3 len throw a URI error exception. 2. Let escape be the substring of string from k to k plus 3. 3. Let b be parse hex octet string k plus 1. If b is not an integer, throw a URI error exception. V set k to k plus 2. V. Let n be the number of leading 1 bits in b. 7. If n equals 0, then let a SCI char be the code unit whose numeric value is b. If preserve escape set contains a SCI char, set s to escape. Otherwise, set s to a SCI char. 8. Else, if n equals 1 or n, 4. Throw a URI error exception. Let octets be b. Let j be 1. Repeat. While j, n, a set k to k plus 1, b if k plus 3, len. Throw a URI error exception. See if the code unit at index k within string is not the code unit 0 times 0025 %. Throw a URI error exception. D let continuation byte be parse hex octet string k plus 1. E if continuation byte is not an integer, throw a URI error exception. F append continuation byte to octets. G set k to k plus 2. H set j to j plus 1. Assert the length of octets is n. If octets does not contain a valid UTF-8 encoding of a Unicode code point, throw a URI error exception. Let v be the code point obtained by applying the UTF-8 transformation to octets. That is, from a list of octets into a 21-bit value. Set s to UTF-16 encode code point. V. Set r to the string concatenation of r and s. D. E. Return r. Set k to k plus 1. Note RFC 3629 prohibits the decoding of invalid UTF-8 octet sequences. For example, the invalid sequence 0xc00 times 80 must not decode into the code unit 0 times 0000. Implementations of the decode algorithm are required to throw a URI error when encountering such invalid sequences. ECMA International 2024 413. 1926 7 parse hex octet string position. The abstract operation parse hex octet takes argument string, a string, and position, a non-negative integer, and returns either a non-negative integer or a non-empty list of syntax error objects. It parses a sequence of 2 hexadecimal characters at the specified position in string into an unsigned 8-bit integer. It performs the following steps when called. Let len be the length of string. Assert position plus 2 len. Let hex digits be the substring of string from position to position plus 2. Let parse result be parse text. String to code points. Hex digits. Hex digits. Sep. If parse result is not a parse node, return parse result. Let n be the MV of parse result. Assert n is in the inclusive interval from 0 to 255. Return n. 9.3 Constructor properties of the global object 193. 1 aggregate error C205711993 2 array C2311993 3 array buffer C2514993 4 begins C2121993 5 begins 64 array C2325993 6 begins 64 array C2325993 3, 7 boolean, C2 0, 3, 1, 9, 3, 8 data view, C2 5, 3, 2, 9, 3, 9 date, C2 1, 4, 2, 14. Copyright sign, ECMA International 2024. The 19th of March 2010 error, C2 0, 5, 1. The 9th of March 2011 eval error, C2 0, 5, 5, 1. The 9th of March 2012 finalization registry, C2 6, 2, 1. The 9th of March 2013 float 32 array, C2 3, 2, 5. The 9th of March 2014 float 64 array, C2 3, 2, 5. The 9th of March 2015 function, C2 0, 2, 1. The 9th of March 2016 int 8 array, C2 3, 2, 5. The 9th of March 2017 int 16 array, C2 3, 2, 5. The 9th of March 2018 int 32 array, C2 3, 2, 5. The 9th of March 2019 map, C2 4, 1, 1. The 9th of March 2020 number, C2 1, 1, 1. The 9th of March 2021 object, C2 0, 1, 1. The 9th of March 2022 promise, C2 7, 2, 3. ECMA International 2024. 15. The 19th of March 2023 proxy, C2 8, 2, 1. The 9th of March 2024 range error, C2 0, 5, 5, 2. The 9th of March 2025 reference error, C2 0, 5, 5, 3. The 9th of March 2026 regexp, C2 2, 2, 4. The 19th of March 2027 set, C2 4, 2, 1. The 9th of March 2028 shared array buffer, C2 5, 2, 3. The 9th of March 2029 string, C2 2, 1, 1. The 9th of March 1930 symbol, C2 0, 4, 1. The 9th of March 1931 syntax error, C2 0, 5, 5, 4. The 9th of March 1932 type error, C2 0, 5, 5, 5. The 9th of March 1933 int 8 array, C2 3, 2, 5. The 9th of March 1934 runt 8 clamped array, C2 3, 2, 5. The 9th of March 1935 int 16 array, C2 3, 2, 5, 16. Copyright sign, ECMA International 2024. The 19th of March 1936 int 32 array, C2 3, 2, 5. The 9th of March 1937 URI error, C2 0, 5, 5, 6. The 9th of March 1938 week map, C2 4, 3, 1. The 9th of March 1939 week ref, C2 6, 1, 1. The 9th of March 1940 week set, C24.4, 9.4 other properties of the global object, 9, 4, 1 atomics, C25.4, 19, 4, 2 JSON, C25.5, 19, 4, 3 math, C21.3, 19, 4, 4 reflect, C28.1, 0 fundamental objects, 0.1 objects, 0, 1, 1 the object constructor. The object constructor is %object is the initial value of the object property of the global object, creates a new, ordinary object when called as a constructor, performs a type conversion when called as a function rather than as a constructor, may be used as the value of an extends clause of a class definition. ECMA International 2024 417 20 1 1 1 object value. This function performs the following steps when called. If new target is neither undefined nor the active function object, then return ordinary create from constructor new target %object prototype %. If value is either undefined or null, return ordinary object create %object prototype % return to object value 0 1 2 properties of the object constructor. The object constructor has an internal slot whose value is %function prototype has a length property whose value is 1, has the following additional properties 0 1 2 1 object assign target Sources. This function copies the values of all of the enumerable own properties from one or more source objects to a target object. It performs the following steps when called. Let be. To object. Target. If only one argument was passed. Return to. For each element next source of sources. Do. If next source is neither undefined nor null, then I let from B. To object. Next source. 2. Let keys be from 3. For each element next key of keys, do let desk be from next key. If desk is not undefined and desk is true, then a let proper value be. Get from next key be perform. Set to next key proper value true. Return to. The length property of this function is 2, 0, 1, 2. To object create. O. Properties. This function creates a new object with a specified prototype. It performs the following steps when called. If O is not an object and O is not null, throw a type error exception. Let obj be ordinary object create. O. If properties is not undefined, then error return. Object defined properties. Obj properties 4. Return obj 0, 1, 2, 3. Object defined properties. O. Properties. This function adds own properties and or updates the attributes of existing own properties of an object. It performs the following steps when called. 18. Copyright sign. ECMA International 2024. 1. If O is not an object, throw a type error exception. Return. Object defined properties. O. Properties. 0, 1, 2, 3. 1. Object defined properties. O. Properties. The abstract operation object defined properties takes arguments O, an object, and properties, an ECMAScript language value, and returns either a normal completion containing an object or a throw completion. It performs the following steps when called. Let props be. To object. Properties. Let keys be props. Let descriptors be a new empty list. For each element next key of keys, do a let prop desk be props. Next key be if prop desk is not undefined and prop desk is true, then I let desk obj be. Get props. Next key 2. Let desk be. To property descriptor. Desk obj 3. Append the record desk to descriptors. For each element property of descriptors, do a perform. Define property or throw. O. Property 6. Return O. 0, 1, 2. For object defined property. O. P. Attributes. This function adds an own property and or updates the attributes of an existing own property of an object. It performs the following steps when called. If O is not an object, throw a type error exception. Let key be. To property key, P. Let desk be. To property descriptor, attributes, perform. Define property or throw. O. Key. Desk. Return O. 0, 1, 2, 5. Object entries. O. This function performs the following steps when called. Let obj be. To object. O. Let entry list be. Enumerable own properties. Obj. Key plus value. Return create array from list. Entry list. 0, 1, 2, 6. Object freeze. O. This function performs the following steps when called. If O is not an object, return O. Let status be. Set integrity level. O. Frozen if status is false. Throw a type error exception. Return O. 0, 1, 2, 7. Object from entries. Iterable. This function performs the following steps when called. Perform. Require object coercible. Iterable. Let obj be ordinary object create. Object prototype. Assert. Obj is an extensible ordinary object with no own properties. ECMA International 2024 419. 4. Let closure be a new abstract closure with parameters, key, value, that captures obj and performs the following steps when called. A let property key be. To property key be perform. Create data property or throw. Obj, property key, value. See return undefined. Let adder be create built-in function. Closure. 2. Return. Add entries from iterable. Obj, iterable. Adder. Note the function created for adder is never directly accessible to ECMAScript code. 0, 1, 2. 8 object get own property descriptor. O. P. This function performs the following steps when called. Let obj be. To object. O. Let key be. To property key. P. Let desk be obj. Key. Return from property descriptor. Desk. 0, 1, 2, 9 object get own property descriptors. O. This function performs the following steps when called. Let obj be. Capital T. O. Object. O. Let own keys be obj. Let descriptors be ordinary object create. Percent object prototype percent. For each element key of own keys. Do. A let desk be obj. Key. B. Let descriptor be from property descriptor. Desk. See if descriptor is not undefined. Perform. Create data property or throw. Descriptors. Key. Descriptor. Return descriptors. 0, 1, 2, 1, 0 object get own property names. O. This function performs the following steps when called. Return create array from list. Get own property keys. O. String. 0, 1, 2, 1, 1 object get own property symbols. O. This function performs the following steps when called. Return create array from list. Get own property keys. O. Symbol 2, 0, 1, 2, 1, 1, 1 get own property keys. O. Type. The abstract operation get own property keys takes arguments so, an ECMAScript language value, and type, string or symbol, and returns either a normal completion containing a list of property keys or a throw completion. It performs the following steps when called. Let obj be. To object. O. Let keys be obj. Let name list be a new empty list. For each element next key of keys. Do. If next key is a symbol and type is symbol, or if next key is a string and type is string, then I append next key to name list. 5. Return name list 420. ECMA International 2024. 20, 1, 2, 1, 2. Object get prototype of O. This function performs the following steps when called. Let obj be. To object. O. Return obj. 0, 1, 2, 1, 3 object group by items. Callback should be a function that accepts 2 arguments grouped by calls callback once for. Note, each element in items, in ascending order, and constructs a new object. Each value returned by callback is coerced to a property key. For each such property key, the result object has a property whose key is that property key and whose value is an array containing all the elements for which the callback return value coerced to that key. Callback is called with 2 arguments. The value of the element and the index of the element. The return value of group by is an object that does not inherit from percent object prototype percent. This function performs the following steps when called. Let groups be. Group by items. Callback property. Let obj be ordinary object create. Null for each record. G of groups. Do. Let elements be create array from list. G. Be perform. Create data property or throw. Obj. G. Return obj. 0, 1, 2, 1, 4 object has own. O. P. This function performs the following steps when called. Let obj be. To object. O. Let key be. To property key. P. Return. Has own property. Obj. Key. 0, 1, 2, 1, 5 object is. Value 1. Value 2. This function performs the following steps when called. Return same value. Value 1. Value 2. 0, 1, 2, 1, 6 object is extensible. O. This function performs the following steps when called. If O is n but an object, return false. Return is extensible. O. 0, 1, 2, 1, 7 object is frozen. O. This function performs the following steps when called. If O is not an object, return true. Return. Test integrity level. O. Frozen. ECMA International 2024 421 20 1 2 1 8 object is sealed. O. This function performs the following steps when called. If O is not an object, return true. Return. Test integrity level. O. Sealed. 0, 1, 2, 1, 9 object keys. O. This function performs the following steps when called. Let obj be. To object. O. Let keylist be. Enumerable own properties. Obj. Key. Return create array from list. Key list. 0, 1, 2, 2, 0. Object prevent extensions. This function performs the following steps when called. If O is not an object, return O. Let status be O. If status is false, throw a type error exception. Return O. 0, 1, 2, 2, 1. Object prototype. The initial value of object prototype is the object prototype object. This property has the attributes false, 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 0, 1, 2, 2, 2. Object seal. This function performs the following steps when called. If O is not an object, return O. Let status be set integrity level sealed. If status is false, throw a type error exception. Return O. 0, 1, 2, 2, 3. Object set prototype of proto. This function performs the following steps when called. Set O2. Require object coercible. If proto is not an object and proto is not null, throw a type error exception. If O is not an object, return O. Let status be proto. If status is false, throw a type error exception. Return O. 0, 1, 2, 2, 4. Object values. This function performs the following steps when called. Let obj be to object. Let value list be enumerable own properties. Obj value. Return create array from list. Value list. 22. ECMA International 2024. 201. 3 properties of the object prototype object. The object prototype object is %object prototype %, has an internal slot whose value is true, has the internal methods defined for ordinary objects, except for the method, which is as defined in 1, 0, 4, 7, 1. Thus, it is an immutable prototype exotic object, has an internal slot whose value is null, 0, 1, 3, 1. Object prototype constructor. The initial value of object prototype constructor is %object %, 0, 1, 3, 2. Object prototype has own property, v. This method performs the following steps when called. Let p be to property key, v. Let o be to object. This value return has own property o. P 0, 1, 3, 3. Object prototype is prototype of v. This method performs the following steps when called. If v is not an object, return false. Let o be to object. This value repeat a set v2. V is null. Return false. See if same value. V is true. Return true. 0, 1, 3, 4. Object prototype property is enumerable. V. This method performs the following steps when called. Let p be to property key, v. Let o be to object. This value. Let desk be p. If desk is undefined, return false. Return desk. Note 1. This method does not consider objects in the prototype chain. Note the ordering of steps 1 and 2 is chosen to ensure that any exception that would have been thrown by step 1 in previous editions of this specification will continue to be thrown even if this value is undefined or null. Note the ordering of steps 1 and 2 preserves the behavior specified by previous editions of this specification for the case where v is not an object and this value is undefined or null. Copyright sign, ECMA International 2024 423. Note 2. The ordering of steps 1 and 2 is chosen to ensure that any exception that would have been thrown by step 1 in previous editions of this specification will continue to be thrown even if this value is undefined or null. 0, 1, 3, 5. Object prototype to locale string, reserved 1, reserved 2. This method performs the following steps when called. Let o be this value. Return. Invoke o to string. The optional parameters to this method are not used but are intended to correspond to the parameter pattern used by ECMA 402 to locale string methods. Implementations that do not include ECMA 402 support must not use those parameter positions for other purposes. Note 2. ECMA 402 intentionally does not provide an alternative to this default implementation. 0, 1, 3, 6. Object prototype to string. This method performs the following steps when called. If this value is undefined, return object undefined. If this value is null, return, object null, let O be. To object, this value, let is array be. Is array, O, if is array is true, let boolten tag be array, else if O has an internal slot. Let boolten tag be arguments, else if O has an internal method. Let boolten tag be function, else if O has an internal slot. Let boolten tag be error, else if O has an internal slot. Let boolten tag be boolean, 0, else if O has an internal slot. Let boolten tag be number, 1, else if O has an internal slot. Let boolten tag be string, 2, else if O has an internal slot. Let boolten tag be date, 3, else if O has an internal slot. Let boolten tag be regexp, 4, else. Let boolten tag be object, 5. Let tag be get, oh, add at to string tag, 6. If tag is not a string, set tag to boolten tag, 7. Return the string concatenation of object, tag, and note 1. This method provides a generic to locale string implementation for objects that have no locale sensitive to string behavior. Array, number, date, and percent typed array percent provide their own locale sensitive to locale string methods. Note historically, this method was occasionally used to access the string value of the internal slot that was used in previous editions of this specification as a nominal type tag for various built-in objects. The above definition of toString preserves compatibility for legacy code that uses toString as a test for those specific kinds of built-in objects. It does not provide a reliable type testing mechanism for other kinds of built-in or program-defined objects. In addition, programs can use at toString tag in ways that will invalidate the reliability of such legacy type tests. 24 ECMA International 2024 2013 object prototype value of this method performs the following steps when called. 1. Return. To object, this value, normative optional, legacy 0, 1, 3, 8 object prototype, prota, object prototype, proto is an accessor property with attributes, false, true. The attributes are defined as follows, 0, 1, 3, 8, 1 get object prototype, prota, the value of the, let O be. To object, this value, return, O, 0, 1, 3, 8, to set object prototype, prota, the value of the, let O be. Require object coercible, this value, if proto is not an object and proto is not null, return undefined. If O is not an object, return undefined. Let status be O proto, if status is false, throw a type error exception, return undefined. Normative optional, legacy 0, 1, 3. Mine legacy object prototype accessor methods 0, 1, 3, 9, 1 object prototype, define getter, p, getter. This method performs the following steps when called. Let O be. To object, this value, if is callable, getter, is false. Throw a type error exception. Let desc be property descriptor, true, true. Let key be. To property key, p, perform. Define property or throw, O, key, desk, return undefined. ECMA International 2024 425 20 1 3 9 2 object prototype, define setter, p, setter. This method performs the following steps when called. Let O be. To object, this value, if is callable, setter, is false. Throw a type error exception. Let desc be property descriptor, true, true. Let key be. To property key, p, perform. Define property or throw, O, key, desk, return undefined. 0, 1, 3, 9, 3 object prototype, lookup getter, p. This method performs the following steps when called. Let O be. To object, this value, let key be. To property key, p, repeat, ls desk be. O, key, b if desk is not undefined. Then, I if is accessor descriptor, desk, is true, return desk 2. Return undefined, c set O2. O, d if O is null, return undefined, 0, 1, 3, 9, 4 object prototype, lookup setter, p. This method performs the following steps when called. Let O be. To object, this value, low key B. To property key, P, repeat, ls desk B. O, key, B if desk is not undefined. Then, I if is access a descriptor, desk, is true, return desk 2. Return undefined, C set O2. O, D if O is null, return undefined, 0, 1. 4 properties of object instances. Object instances have no special properties beyond those inherited from the object prototype object. 0.2 function objects. 0, 2. 1. The function constructor. The function constructor is %function is the initial value of the function property of the global object. Creates and initializes a new function object when called as a function rather than as a constructor. Thus the function call function is equivalent to the object creation expression new function with the same arguments. 26. ECMA International 2024. Comma may be used as the value of an extends clause of a class definition. Subclass constructors that intend to inherit the specified function behavior must include a supercall to the function constructor to create and initialize a subclass instance with the internal slots necessary for built-in function behavior. All ECMAScript syntactic forms for defining function objects create instances of function. There is no syntactic means to create instances of function subclasses except for the built-in generator function, async function, and async generator function subclasses. 0, 2, 1. 1 function, parameter args, body arg. The last argument, if any, specifies the body executable code of a function. Any preceding arguments specify formal parameters. This function performs the following steps when called. Let C be the active function object. If body arg is not present, set body arg to the empty string. Return. Create dynamic function. C. New target. Normal. Parameter args. Body arg. 0, 2, 1, 1. 1. Create dynamic function. Constructor. New target. Kind. Parameter args. Body arg. The abstract operation create dynamic function takes arguments constructor, a constructor, new target, a constructor, kind normal, generator, async, or async generator, parameter args, a list of ECMAScript language values, and body arg, an ECMAScript language value, and returns either a normal completion containing an ECMAScript function object or a throw completion constructor as the constructor function that is performing this action. New target is the constructor that new was initially applied to. Parameter args and body arg reflect the argument values that were passed to constructor. It performs the following steps when called. If new target is undefined, set new target to constructor. If kind is normal, then a let prefix be function, b let expa sim be the grammar symbol function expression, c let body sim be the grammar symbol function body, yield, await, d let parameter sim be the grammar symbol formal parameters, yield, await, e let fallback proto be %function prototype else if kind is generator, then a let prefix be function, b let expa sim be the grammar symbol generator expression, c let body sim be the grammar symbol generator body, d let parameter sim be the grammar symbol formal parameters, plus yield, await, e let fallback proto be %generator function prototype else if kind is async. Then, a let prefix be async function, b let expa sim be the grammar symbol async function expression, c let body sim be the grammar symbol async function body, d let parameter sim be the grammar symbol formal parameters, yield, plus await, e let fallback proto be %async function prototype else, a assert. Kind is async generator, b let prefix be async function, c let expa sim be the grammar symbol async generator expression. Note it is permissible but not necessary to have one argument for each formal parameter to be specified. For example, all three of the following expressions produce the same result. New function, a, b, c, returner plus b plus c, new function, a, b, c, returner plus b plus c, new function, a, B, C, returner plus B plus C, ECMA International 2024 427, D let body sim be the grammar symbol async generator body, E let parameter sim be the grammar symbol formal parameters, plus yield, plus await. F let fallback pro to be %async generator function prototype %. Let arg count be the number of elements in parameter args. Let parameter strings be a new empty list. For each element arg of parameter args, do append to string arg to parameter strings. Let body string be to string body arg 0. Let current realm be the current realm record 1. Perform. Host ensure can compile strings current realm parameter strings body string false 2. Let p be the empty string 3. If arg count 0, then a set p to parameter strings 0. B let k be 1. C repeat. While k arg count. I let next arg string be parameter strings k 2. Set p to the string concatenation of p, a comma, and next arg string 3. Set k to k plus 1 4. Let body parse string be the string concatenation of 0 times 0 0 0 line feed body string and 0 times 0 0 0 line feed 5. Let source string be the string concatenation of prefix anonymous p 0 times 0 0 0 line feed body parse string and 6. Let source text be string to code points source string 7. Let parameters be parse text string to code points p parameter sum 8. If parameters is a list of errors, throw a syntax error exception 9. Let body be parse text string to code points body parse string body sum 0. If body is a list of errors, throw a syntax error exception 1. Note: the parameters and body are parsed separately to ensure that each is valid alone. For example, new function, does not evaluate to a function 2. Note: if this step is reached, source text must have the syntax of expresum, although the reverse implication does not hold. The purpose of the next two steps is to enforce any early error rules which apply to expresum directly. 3. Let expa be parse text, source text, expresum. 4. If expa is a list of errors, throw a syntax error exception. 5. Let proto be get prototype from constructor, new target, fallback proto. 6. Let env be current realm. 7. Let private env be null. 8. Let f be ordinary function create, proto, source text, parameters, body, non-lexical this, env, private env. 9. Perform set function name, f, anonymous 0. If kind is generator, then a let prototype be ordinary object create, %generator function prototype %be perform. Define property or throw, f, prototype, property descriptor, prototype, true, false, false, 1. Else if kind is a sync generator, then, a let prototype be ordinary object create, %async generator function prototype %be perform. Define property or throw, f, prototype, property descriptor, prototype, true, false, false, 2. Else if kind is normal, then, a perform make constructor, f. 3. Note: functions whose kind is async are not constructible and do not have an internal method or a prototype property. 4. Return f. 428. ECMA International 2024. Note: create dynamic function defines a prototype property on any function it creates whose kind is not async to provide for the possibility that the function will be used as a constructor. 2. Two properties of the function constructor. The function constructor is itself a built-in function object, has an internal slot whose value is %function prototype %, has a length property whose value is 1, has the following properties 0, 2, 1 function prototype. The value of function prototype is the function prototype object. This property has the attributes false, 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 0, 2, 3 properties of the function prototype object. The function prototype object is %function prototype is itself a built-in function object, accepts any arguments and returns undefined when invoked, does not have an internal method, It cannot be used as a constructor with the new operator. Has an internal slot whose value is %. Object prototype %. Does not have a prototype property. Has a length property whose value is +0. Has a name property whose value is the empty string. 0, 2, 3, 1 function prototype apply. This array. This method performs the following steps when called. Let func be the this value if is callable. Func is false. Throw a type error exception if array is either undefined or null. Then a perform prepare for tail cal l be return. Call func this let list be. Create list from array like array perform prepare for tail call return. Call func this list. Note the function prototype object is specified to be a function object to ensure compatibility with ECMAScript code that was created prior to the ECMAScript 2015 specification. Note 1 that this arg value is passed without modification as the this value. This is a change from edition 3, where an undefined or null this arg is replaced with the global object and to object is applied to all other values and that result is passed as the this value. Even though this arg is passed without modification, non-strict functions still perform these transformations upon entry to the function. Note 2 if func is either an arrow function or a bound function exotic object, then this arg will be ignored by the function in step 6. ECMA International 2024 429 2023 function prototype bind. This args. This method performs the following steps when called. Let target be the this value if is callable. Target is false. Throw a type error exception. Let f be. Bound function create. Target this args. Let l be 0. Let target has length be. Has own property. Target length. If target has length is true, then a let target len be. Get target length be if target len is a number. Then if target len is plus, then 1. Set l to +2. Else if target len is, then 1. Set l to 0, 3. Else let target len as int be. To an integer or infinity, target len assert. Target len as int is finite. Let arg count be the number of elements in args. Set l to max. Target len as int. Arg count 0. Perform set function length f. L. Let target a name be. Get target name. If target name is not a string, set target name to the empty string. 0. Perform set function name. F. Target name. Bound 1. Return f. 0, 2, 3. 3 function prototype call. This args. This method performs the following steps when called. Let func be the this value if is callable. Func is false. Throw a type error exception. Perform prepare for tail call. Return. Call func this args. Note 1 function objects created using function prototype binder exotic objects. They also do not have a prototype property. Note 2 if target is either an arrow function or a bound function exotic object, then this arg passed to this method will not be used by subsequent calls to f. Note 1 that this arg value is passed without modification as the this value. This is a change from edition 3, where an undefined or null this arg is replaced with the global object and to object is applied to all other values and that result is passed as the this value. Even though this arg is passed without modification, non-strict functions still perform these transformations upon entry to the function. Note 2 if func is either an arrow function or a bound function exotic object, then this arg will be ignored by the function in step 4. 0, 2, 3, 4 function prototype constructor. The initial value of function prototype constructor is %function %30. Copyright sign, ECMA International 2024 2023 5 function prototype to string. This method performs the following steps when called. Let func be the this value. If func is an object, func has an internal slot. Func is a sequence of Unicode code points, and host has source text available. Func is true, then a return code points to string. Func. If func is a built-in function object, return an implementation-defined string source code representation of func. The representation must have the syntax of a native function. Additionally, if func has an internal slot and func is a string, The portion of the return string that would be matched by native function accessor opt property name must be the value of func. If func is an object and is callable, func is true. Return an implementation-defined string source code representation of func. The representation must have the syntax of a native function. Throw a type error exception. Native function native function accessor opt property name, yield, await opt, formal parameters, yield, await, native code, native function accessor, get, set, 0, 2, 3, 6 function prototype, at has instance, v. This method performs the following steps when called. Let f be the this value. Return. Ordinary has instance, f, v. This property has the attributes, false, false, false. This is the default implementation of at has instance that most functions inherit. At has instance. Note is called by the instantiaf operator to determine whether a value is an instance of a specific constructor. An expression such as v instantiaf f evaluates as f at has instance v. A constructor function can control which objects are recognized as its instances by instantiaf by exposing a different at has instance method on the function. This property is non-writable and non-configurable to prevent tampering that could be used to globally expose the target function of a bound function. The value of the name property of this method is symbol his instance 202. 4 function instances. Every function instance is an ECMAScript function object and has the internal slots listed in table 30. Function objects created using the function prototype bind method 20232 have the internal slots listed in table 31. Function instances have the following properties. ECMA International 2024 431 2024 1 length. The value of the length property is an integral number that indicates the typical number of arguments expected by the function. However, the language permits the function to be invoked with some other number of arguments. The behavior of a function when invoked on a number of arguments other t, and the number specified by its length property depends on the function. This property has the attributes false, false, true 0, 2, 4. To name, the value of the name property is a string that is descriptive of the function. The name has no semantic significance but is typically a variable or property name that is used to refer to the function at its point of definition in ECMAScript source text. This property has the attributes false, false, true, anonymous functions. Objects that do not have a contextual name associated with them by the specification use the empty string as the value of the name property 0, 2, 4. 3 prototype function instances that can be used as a constructor have a prototype property. Whenever such a function instance is created, another ordinary object is also created and is the initial value of the function's prototype property. Unless otherwise specified, the value of the prototype property is used to initialize the internal slot of the object created when that function is invoked as a constructor. This property has the attributes true, false, false 0, 2, 5. Host has source text available. Func. The host-defined abstract operation host has source text available takes argument func, a function object, and returns a boolean. It allows host environments to prevent the source text from being provided for func. An implementation of host has source text available must conform to the following requirements. It must be deterministic with respect to its parameters. Each time it is called with a specific func as its argument, it must return the same result. The default implementation of host has source text available is to return true 0.3 boolean objects 0, 3, 1. The boolean constructor. The boolean constructor is %boolean% is the initial value of the boolean property of the global object, creates and initializes a new boolean object when called as a constructor, performs a type conversion when called as a function rather than as a constructor, may be used as the value of an extends clause of a class definition. Subclass constructors that intend to inherit the specified Boolean behavior must include a supercall to the Boolean constructor to create and initialize the subclass instance with the internal slot. Function objects created using function prototype bind, or by evaluating a method definition. Note, that is not a generator method or a sync generator method, or an arrow function do not have a prototype property. 32. ECMA International 2024 2031 1 Boolean value. This function performs the following steps when called. Let B be to Boolean value. If new target is undefined, return B. Let O be ordinary. Create from constructor new target %Boolean prototype %set O end data to B. Return O 0 3 2 properties of the Boolean constructor. The Boolean constructor has an internal slot whose value is %function prototype has the following properties: 0 3 2 1 Boolean prototype. The initial value of Boolean prototype is the Boolean prototype object. This property has the attributes false, false, false. 0 3 3 properties of the Boolean prototype object. The Boolean prototype object is %Boolean prototype is an ordinary object, is itself a Boolean object. It has an internal slot with the value false, has an internal slot whose value is %object prototype %0 3 3 1 Boolean prototype constructor. The initial value of Boolean prototype constructor is %Boolean %0 3 3 2 Boolean prototype to string. This method performs the following steps when called. Let B be this Boolean value, this value. If B is true, return true, else return false. 0 3 3 3 Boolean prototype value of. This method performs the following steps when called. 1. Return this Boolean value, this value. 0 3 3 3 1 This Boolean value, value. The abstract operation this Boolean value takes argument value, an ECMAScript language value, and returns either a normal completion containing a Boolean or a throw completion. It performs the following steps when called. If value is a Boolean, return value. If value is an object and value has an internal slot, then ECMA International 2024 433 a let B be value. B assert B is a Boolean. C return B. Throw a type error exception. 0 3 4 properties of Boolean instances. Boolean instances are ordinary objects that inherit properties from the Boolean prototype object. Boolean instances have an internal slot. The internal slot is the Boolean value represented by this Boolean object. 0.4 symbol objects. 0 4 1 The symbol constructor. The symbol constructor is %symbol is the initial value of the symbol property of the global object. Returns a new symbol value when called as a function. Is not intended to be used with the new operator. Is not intended to be subclassed. May be used as the value of an extends clause of a class definition, but a supercall to it will cause an exception. 0 4 1 1 symbol description. This function performs the following steps when called. If new target is not undefined, throw a type error exception. If description is undefined, let desc string be undefined. Else, let desc string be to string description. Return a new symbol whose is desc string. 0 4 2 properties of the symbol constructor. The symbol constructor has an internal slot whose value is %function prototype has the following properties. 0 4 2 1 symbol async iterator. The initial value of symbol async iterator is the well-known symbol at async iterator, table 1. This property has the attributes false, false, false. 0 4 2 2 symbol 4 key. This function performs the following steps when called. Let string key be to string key for each element E of the global symbol registry list. Do if same value E. Assert global symbol registry does not currently contain an entry for string key. Let new symbol be a new symbol whose is string key. 34. ECMA International 2024 5. Append the record new symbol to the global symbol registry list. Return new symbol. The global symbol registry is an append-only list that is globally available. It is shared by all realms. Prior to the evaluation of any ECMAScript code, it is initialized as a new empty list. Elements of the global symbol registry are records with the structure defined in Table 60. Table 60, global symbol registry record fields. 0 4 2 3 symbol has instance. The initial value of symbol has instance is the well-known symbol at has instance. Table 1. This property has the attributes false, 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 0, 4, 2. For symbol is concat spreadable. The initial value of symbol is concat spreadable is the well-known symbol at is concat spreadable. Table 1. This property has the attributes false, 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 0, 4, 2, 5 symbol iterator. The initial value of symbol iterator is the well-known symbol at iterator. Table 1. This property has the attributes false, 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 0, 4, 2, 6 symbol key 4, sim. This function performs the following steps when called. If sim is not a symbol, throw a type error exception. Return key for symbol, sim, 0, 4, 2, 7 symbol match. The initial value of symbol matches the well-known symbol at match. Table 1. This property has the attributes false, 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 0, 4, 2, 8 symbol match all. The initial value of symbol match all is the well-known symbol at match all. Table 1. This property has the attributes false, 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 field name, value, usage, key, a string key used to globally identify a symbol, a symbol that can be retrieved from any realm. Copyright sign, ECMA International 2024 435 2042 9 symbol prototype. The initial value of symbol prototype is the symbol prototype object. This property has the attributes false, 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 0, 4, 2, 1 0 symbol replace. The initial value of symbol replace is the well-known symbol at replace. Table 1. This property has the attributes false, 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 0, 4, 2, 1 1 symbol search. The initial value of symbol search is the well-known symbol at search. Table 1. This property has the attributes false, 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 0, 4, 2, 1 2 symbol species. The initial value of symbol species is the well-known symbol at species. Table 1. This property has the attributes false, 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 0, 4, 2, 1 3 symbol split. The initial value of symbol split is the well-known symbol at split. Table 1. This property has the attributes false, 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 0, 4, 2, 1 4 symbol to primitive. The initial value of symbol to primitive is the well-known symbol at to primitive. Table 1. This property has the attributes false, 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 0, 4, 2, 1 5 symbol to string tag. The initial value of symbol to string tag is the well-known symbol at to string tag. Table 1. This property has the attributes false, 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 0, 4, 2, 1 6 symbol unscopables. The initial value of symbol unscopables is the well-known symbol at unscopables. Table 1. This property has the attributes false, 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 0, 4, 3 properties of the symbol prototype object. The symbol prototype object is %symbol prototype % is an ordinary object, is not a symbol instance and does not have an internal slot, has an internal slot whose value is %object prototype % 36. ECMA International 2024 2043 1 symbol prototype constructor. The initial value of symbol prototype constructor is %symbol % 2043 to get symbol prototype description. Symbol prototype description is an accessor property whose set accessor function is undefined. Its getAccessor function performs the following steps when called. Let S be this value. Let sim be this symbol value. S return sim 0, 4, 3. 3 symbol prototype to string. This method performs the following steps when called. Let sim be this symbol value. This value. Return symbol descriptive string. Sim 0, 4, 3, 3. 1 symbol descriptive string. Sim. The abstract operation symbol descriptive string takes argument sim, a symbol, and returns a string. It performs the following steps when called. Let desc be sim's value. If desc is undefined, set desc to the empty string. Assert desc is a string. Return the string concatenation of symbol desc and 0, 4, 3, 4 symbol prototype value of. This method performs the following steps when called. 1. Return this symbol value, this value, 0, 4, 3, 4, 1 this symbol value, value. The abstract operation this symbol value takes argument value, an ECMAScript language value, and returns either a normal completion containing a symbol or a throw completion. It performs the following steps when called. If value is a symbol, return value, capital I. If value is an object and value has an internal slot, then let S be value, B assert. S is a symbol, C return S. Throw a type error exception, 0, 4, 3, 5 symbol prototype. Add at to primitive. Hint, this method is called by ECMAScript language operators to convert a symbol object to a primitive value. It performs the following steps when called. Return this symbol value, this value. ECMA International 2024 437. Note the argument is ignored. This property has the attributes false, false, true. The value of the name property of this method is symbol to primitive, 0, 4, 3, 6 symbol prototype. Add at to string tag. The initial value of the add at to string tag property is the string value symbol. This property has the attributes false, false, true, 0, 4. 4 properties of symbol instances. Symbol instances are ordinary objects that inherit properties from the symbol prototype object. Symbol instances have an internal slot. The internal slot is the symbol value represented by the symbol object. 0, 4, 5 abstract operations for symbols 2, 0, 4, 5, 1 key for symbol, sim. The abstract operation key for symbol takes argument sim, a symbol, and returns a string or undefined. If sim is in the global symbol registry, C20, 4, 2, 2, the string used to register sim will be returned. It performs the following steps when called. For each element of the global symbol registry list, do if same value, E, sim, is true, return E. Assert, global symbol registry does not currently contain an entry for sim, return undefined. 0.5 error objects. Instances of error objects are thrown as exceptions when runtime errors occur. The error objects may also serve as base objects for user-defined exception classes. When an ECMAScript implementation detects a runtime error, it throws a new instance of one of the native error objects defined in 2.0.5, or a new instance of aggregate error object defined in 2.0.5.7. Each of these objects has the structure described below, differing only in the name used as the constructor name instead of native error, in the name property of the prototype object, in the implementation defined message property of the prototype object, and in the presence of the %aggregate error %specific errors property. 0, 5, 1 the error constructor. The error constructor is %error is the initial value of the error property of the global object, creates and initializes a new error object when called as a function rather than as a constructor. Thus the function call error is equivalent to the object creation expression new error, with the same arguments, may be used as the value of an extends clause of a class definition. Subclass constructors that intend to inherit the specified error behavior must include a supercall to the error constructor to create and initialize subclass instances with an internal slot. 38. ECMA International 2024 2.0.5.1. 1 error message. Options. This function performs the following steps when called. If new target is undefined, let new target be the active function object, else let new target be new target. Let O be ordinary create from constructor, new target, %error prototype %. If message is not undefined, then let message be to string message be perform capital C R E A T E capital N O N capital E N U M E R A B L E capital D A T A capital P R O P E R T O message perform install error cause O options return O 0 5 2 properties of the error constructor. The error constructor has an internal slot whose value is %function prototype has the following properties: 0, 5, 2, 1 error prototype. The initial value of error prototype is the error prototype object. This property has the attributes false, 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 0, 5, 3 properties of the error prototype object. The error prototype object is %error prototype is an ordinary object, is not an error instance and does not have an internal slot. Has an internal slot whose value is %object prototype 0, 5, 3, 1 error prototype constructor. The initial value of error prototype constructor is %error 2, 0, 5, 3, 2 error prototype message. The initial value of error prototype message is the empty string 2, 0, 5, 3, 3 error prototype name. The initial value of error prototype name is error 0, 5, 3, 4 error prototype to string. This method performs the following steps when called. Let O be this value. If O is not an object, throw a type error exception. Let name be get O name. If name is undefined, set name to error. Otherwise set name to string name. Let message be get O message. If message is undefined, set message to the empty string. Otherwise set message to string MSG. If name is the empty string, return message. ECMA International 2024 439 8. If message is the empty string, return name. Return the string concatenation of name, the code unit 0 times 0038, colon, the code unit 0 times 0020, space, and message 0, 5, 4 properties of error instances. Error instances are ordinary objects that inherit properties from the error prototype object and have an internal slot whose value is undefined. The only specified uses of is to identify error, aggregate error, and native error instances as error objects within object prototype to string 0, 5, 5 native error types used in this standard. A new instance of one of the native error objects below or of the aggregate error object is thrown when a runtime error is detected. All native error objects share the same structure, as described in 2.0, 5, 6, 0, 5, 5, 1 eval error. The eval error constructor is %eval error %. This exception is not currently used within this specification. This object remains for compatibility with previous editions of this specification. 0, 5, 5, 2 range error. The range error constructor is %range error indicates a value that is not in the set or range of allowable values. 0, 5, 5, 3 reference error. The reference error constructor is %reference error indicate that an invalid reference has been detected. 0, 5, 5, 4 syntax error. The syntax error constructor is %syntax error indicates that a parsing error has occurred. 0, 5, 5, 5 type error. The type error constructor is %type error Type error is used to indicate an unsuccessful operation when none of the other native error objects are an appropriate indication of the failure cause. 0, 5, 5, 6 URI error. The URI error constructor is %URI error indicates that one of the global URI handling functions was used in a way that is incompatible with its definition. 40. Copyright sign. ECMA International 2024.
I don't know, the shortcut to make Siri read stuff. It's not working. But I don't know. I got all the comments replaced, whatever. All the types that are like in a comment. So I'm gonna see how many are left. Okay, now I'm down to it's less. So I'm gonna mass find and replace all these. As this now. Notepad does not work. This program sucks. Alright, so I'm gonna mass replace all these that are left. I tagged whatever the difference is between these two. All the things with comments with this. So I'm gonna replace all these with this. And then I'm almost done because I don't know. Today, tomorrow, next stream, whatever, I'm gonna go through all these and where it's an address, I'll replace it with an A. So now I can finally start converting the 32-bit address arithmetic to 64-bit address arithmetic. But when I was going through however many thousand, I found a few ints, like a lot, I don't know, not too many. I have to replace these two. So far I have all signed ins replaced and all unsigned ints replaced. I replace the signed ins with this, and all the unsigned with this. And now I would assume that all ints without a type, that they are signed like they should be signed. I'm gonna ask chatbot. It's possible that maybe, possibly, in the compiler you can pick a default for a type that doesn't have signed or unsigned. I think that's possible, which would be really annoying I don't want to make another type. So I'm going to ask chatbot, but if chatbot says it's possible that int isn't always signed by default, then I'll have to make another type. I can't just assume it's always signed if it's factual that it could be unsigned if someone messes with compiler settings. So there might also be, I'm gonna check this first. I want to get this shit tagged and then it's done, and then just addressing after that. And after addressing, I can make a little demo to show how fast it is. A little like game demo with like a little box or cube. I'll make it jump around or something in a map. So that's chatbot. I'm gonna see if Siri still works or not. I think it's like stuck or something. It's a modern operating system, you know. I don't know. Talking text is very modern, so it makes sense that it's not gonna work sometimes because it's modern. I'm hitting the shortcut. It's not working. So I said didn't see. Oh, I had the screen up, so whatever, just read that. Is int always signed? I have a feeling it might say no. I really hope it's not going to say no. Okay, so only char. Okay, this is good. But can the compiler, I don't know, ask chatbot again. Okay. It says you can't globally change int to be unsigned by default in standard C compilers. So I'm very happy. That means that I can find all these ints. This saves me time because I thought, oh shit, another thing to account for. That means all these ints are going to be they're all going to be assigned by default. So I have to find where it's an int without the sign and replace. Now I'll just replace it with this whatever. So I'll do that. I'll do this first, then whatever. I gotta check one more thing. And I think I'm done for now. Ah, shit. Looks like there's more than I thought. Damn it. Fuck. Oh my god, stick over. So many. How many fucking ints are there? I swear, I thought I wrote this whole thing and I tagged everything as either signed or unsigned. Crap. This just isn't in. There's so many matches. Oh wait, it's finding print. So that's great. So I'm looking for int the modern operating system, because that's what we are, the days we are now. These are modern operating systems. You program in a text file with text, and writing a program is like moving grains of sand. Every piece of sand makes a sandcastle. When you assemble them all together to make something out of it, and it takes your time's like the water, to put all these teeny little pieces of sand to make a castle. I'm just annoyed, whatever. I hate this. So all the prints are being found and treated as a int. This print has int in it. And in the modern operating system, the modern, like 2025, in the modern operating system, you can't have a keyword like print that's a word as print without having it as separate characters. It would be nice if it's possible to make a word or whatever and place it in a program, in a file, in a folder name as print, and have it be the word print wherever it's at as the word print. And then if you could like click on one of these words and change it to like Bob, and have the modern operating system go, oh, you want to change the word to Bob? Everywhere that you tagged print will be Bob. Because if the modern operating system did that, I wouldn't be sitting here going through a program word by word, replacing 20,000 places where signed int and unsigned int and int. This is fucking ridiculous. So since the modern operating system is modern, the modern operating system doesn't have the ability to make a word that can be like referenced as that word. It's always treated as a broken collection of characters. So all the prints are going to be found as an int, because the year is 2025. We have 3D CAD programs. We don't do CAD these days on paper anymore. Everything is done on the computer. Typography is done. You make fonts on the computer. Typography has fancy formats with Bezier curves, and it's really nice. It's all digital. What the fuck happened to programming? Literally, like really. This is all intentional. There's no reason for programming to be this ridiculous. Okay, so anyways, I'm going to find all these prints and I will replace them. I'm gonna save it back up because this could get fucked up. So everywhere that a print is at, I have to replace it with some other keyword that's not being used. Because remember, this is the modern operating system. Modern, you know. Like, it's new, it's modern. The modern operating system. So I'm gonna have to do Control F and then find if I use print with like a 1. I just have to find anything that's not being used. So then when I look for int, if I use print with 1, This isn't an... This is print with a 1, not with an I. So now, if I do this, then I'll be able to control find and find all the ends. So there's like several extra steps involved to doing this. So I'm gonna like just get this done with for now. The modern operating system. I'm done bitching. I'm gonna find a new place, I guess. Save it back up. I still gotta run it. But I can remove all the prints from the find results, whatever, and then do Control F on int and see how many there might be. There's still a lot. There's enough, then I'm gonna make another type. Because it looks like I'm using them for like system handles and stuff. So it'd probably be best to like specify it with a different tag or whatever. So like instead of giving it like size this one, whatever I'm using for assign one, I'll give like an I or something. And that'll be easier to tell like, oh, this one was an int, it's not assigned in. It would be really nice if I could tag every one of these that I'm replacing right now with a keyword, where if I change this one instance, whatever, it would change across the whole OS in any place that this exact token is used. But that'd be too much to ask for on the modern operating system, because programming is done in text editors with grains of sand, like it's the 1970s, 80s, I don't know. Using a punch card would be more efficient than this. So I'm gonna try to figure out how many ints there are, and I think there's more functions that end in int that I'm gonna have to like carefully replace so I can find all the ends and then carefully rename back to the original name. This stream has been brought to you by the modern operating system. I really like the quality of the stream. Data compression is beautiful. I mean, you can't beat color blotches and color loss, partial data. I mean, what's better than compressed data? I don't know, maybe like lossless data, like no quality loss, that'd be cool too. But compression, compressed data, floating point, in precision, non-precise, that's cool too, you know. It's way cooler than freaking 1-to-1 ratio. You put in, you get out. Why would you want that when you could have data loss? You could have like, you could get shit, you know. I'm gonna like build myself a or like add some more bricks to my sand castle here. I have to find a couple pieces of sand, carefully sift them around, and then sift them back while scooping out a couple new holes, and then carefully saving it, hoping that this ocean, I guess, won't like destroy all my fucking files or like lock up the folder or whatever the fuck it's gonna do, because you never know. It's Visual Studio. It's a crappy compiler. Okay, so now I'm actually done complaining. For now. And it's not just a function print, it's I have like a comment where I say oh god, the word point too. Oh my fucking shit. This is gonna take forever. Fuck. Oh my god. Everything ends in int. What the fuck? I'm gonna get this shit done now. This is pissing me off. Fuck's sake. I can have a sentence that says no point in specifying. That fucking has int in it. Right here, there's int. You see the int? Here, no point, there's an int in it. So like, it's in a comment. And then oh, there's so many. Oh my god. Why did I do this? And I have print whatever. This is a function call. I want to find where I'm using print or whatever. Okay, so I want to find all the prints that are like a function call. So when I remove the function, I put a space. So it's like, now it's not a function call, but it is though, but it's not touching here. So I put a space there. So when I want to find print, I could do like this. And only the ones in use would be touching here. But since I put a space right there, there's a whole lot of these, because this makes int. There's no point in complaining. There's no point. No point in complaining. This also has int in it. Here is an int. No point. So many. Okay, finding and replacing where the print is at, that's risky. I could find and replace and I could mess up somewhere else. Because if I replace a print with like, I'll put like X in here, with PRXNT, if there ever happens to be an XNT, or whatever, I don't know. There's several ways that replacing something can make a combination that'll mess up something else. So I'm going to leave everything as it is. I'm going to go through one by one. I'm going to just carefully replace, because it looks like a lot, but there's only 6,000 of them across 70 files. That's it. Only 6,000. Man. So whatever this 9,000 is, and have 6,000 more to it. But not all of these 6,000. I gotta like figure out which ones are not. I'll remove print and the word point and see how many are left to match. The modern operating system. Modern. Okay, now there is so there's at least 5,000 ints or whatever. I'm gonna save it back up. I'll make this new fucking type with an I. How do I get this shit done? The notepad. This program does not work. I'm done trying to type in Notepad. This thing sucks. I'm gonna like save backups, get some more pop, and I'm gonna like replace Notepad. Notepad sucks. I'm gonna replace, oh my god, come on. 5,000. Well, I'm gonna sort through 6,353 and then fuck this program, and then I'll replace only 5,685 of them because I'm building a sandcastle in the modern operating system. Now, you may be thinking, can't you use a regex? No, regex, it doesn't work. I'll stop complaining now. For now. I'll save it back up. I think there's also another type I gotta find though. I might as well just look while I'm at it. I'm kind of tired. I think it's like UN16_T, or is it this chatbot? I don't remember what it was exactly. Okay, that is it. Alright, so I gotta try to find... I gotta look for uint32_T. Please God, do not let there be any uint_, I have a feeling, 32. I mean, you know what I mean, God. Please don't let there be any. Here we go. Control F. I'm gonna switch for N, not UN. I want to see if either or exists. Yes. Zero matches. This is very good. This means I don't have to look for these, and it means that all I have to simply do is find this program sucks. I hate this program. Holy shit. So there was 0 matches for that, and there's only 5,685 of these across 70 files. So that's less than 10,000. So I'm going to save it back up. I'm going to keep a positive attitude. I'm going to get this done. First, I'm going to save it back up. Then I'm going to run the compiler because I don't want to wait for it to build and then save it back up. Because at that point, I'm not going to want to save it back up because it takes 2 minutes to build. So I'm going to take a break as it builds. And when I get back, I really hope it's going to build. If it doesn't, I'm going to be pissed. Like pissed, I'm going to be so angry. And then I'm going to find the rest of these 5,685. And then I'm going to drink some water. Well, I'm going to drink water after I run the compiler and I get up to walk away. I'm going to need some more pop / soda, however you say it. It doesn't matter. It does though, because pop makes more sense than soda. I'm going to shut up and do something. This computer is very slow. I have it back up, and now I'll run it. And I don't know if it really works though, because 30% of the time this compiler builds something other than what you give it. Just, it'll run old code, it'll run random code, who knows what it does. But 70% of the time, it does build whatever you give it. So I'm hoping that it's going to be one of those 70% chances that what I expect to happen, which is it'll build what's in the folder, because that's what I'm clicking the button for it to do. I'm hoping that it will do that and compile this code. Here we go. I quick rebuild. So far so good. Oh no. Fuck. If at first you don't succeed, you just do it again. What's it missing? Okay, it looks like somewhere something wasn't actually a comment. because the error message is comment undefined identifier. So I'm going to define comment whatever. This program does not work. I'm going to define this whatever as this, and it should build this time, and then next stream I'm gonna find which comment, or there's probably a couple of them that I have to find and replace with this, because I guess it wasn't a comment in a couple places. I don't know, when you're reading through like 20-30,000 lines of code and looking for 20,000 types, because this is a modern operating system, and that's how you write code in the modern operating system. It's highly plausible that I could make a mistake now and then. So I guess I made a mistake. I can't believe I just said that. Oh fuck. I hate Windows. I hate the modern operating system. I should not have to do this. I should originally have been able to make a type, use that type everywhere. If I change it to another type, all places that it's used should be renamed. And it should be possible to pick if it's a live, like a live type, or like live text or static text. So a live text would be like connected or tied to other text. So you change one, it changes the whole web. Or if it's static, that should totally be possible. In the modern, I'm done complaining, whatever. So I'm going to define this comment as this type. I'm going to try to build again. If I can find where the main is, I had it open somewhere. I probably just walked away or something. Oh, it's over here. What's up with the yellow border? It's like really yellow. I don't care. It's just whatever. So instead of main, I'm going to define, I'm going to paste defining the comment as a patch for now, and I'll figure it out tomorrow where I missed tag something wrong. Okay, I'm gonna try to build again. I have a feeling it's not gonna go in my favor. there's a couple places where there's a line ending that was like not correct, so I like removed it because it was a bug technically, but I could have made a bug by fixing the bug. I'm really hoping I didn't make a bug by fixing the bug, because if I did, it's going to show up now. So I'm going to hit build whatever. I'm going to clean the solution first. I click the clean button. I don't think it makes any difference when you click that button. When you click rebuild solution, you get what you get. Your odds are 30-70. So it's building. Okay, so far it's off to a good start. I'm gonna be back before, or I'm gonna leave before errors start popping up possibly. So I'll be back. I don't want to look. I'll see whenever I get back, whatever the result is. And Siri is not working. I'll just restart the computer when I get back though. it looks like it builds. But looks can be deceiving. I have to stop talking and just do stuff. Click run. So it's running. Check the output. Save another backup just because. Restart the computer. Operating systems have been out for what, like, since 1980s or, I don't know, a long time. You'd think that, by now, the modern operating system, since, they've been out for so long, that they would have, figured out the whole, let's not have bugs thing, but I guess operating systems, the modern ones anyways, they still have bugs. I don't know. I don't get it. Even like documentation, like this is a 2009 ECMA 252.262 standard for JavaScript, okay? This is ancient, this is old JavaScript. This standard it's only 200 something pages. So this old, this ancient, this really old, this non-modern, from 2009, this JavaScript standard, it's 241 pages. I'm going to do Command F to find the word leak. I'm looking for the word leak. This ancient 2009 documentation, it doesn't contain the word leak. But when I open up the 2024 documentation for the ECMA 262 JavaScript golden standard that everyone complies with, I look for the word leak. This, it's not a trick question. When I look for the word leak, what do you think comes up? In the modern 2024 JavaScript ECMA 262 standard that everyone implements, all the browsers are like, oh, we abide by the ECMA 262 standard. All of them. The 2024 standard doesn't contain the word leak. The modern 2024 standard. Modern. I don't know, let's see. I'll do Command F and look for the word leak. Oh, it does contain the word leak. It does contain the word leak. I'm kind of tired. I'm like really mixing my words. I even mixed words the way I just said it. Inside the 2024 standard, the modern JavaScript standard, I'm sure that this showed up a couple years before. I don't know when. I don't think it's worth time investigating when exactly. I'm just saying it's here now. But they say a weak map or whatever is unlikely to be collected and could leak memory resources in implementations. So they're saying that in modern JavaScript, leaking memory resources is acceptable because these are modern times. There's like a quote that doesn't like use the word modern but like make a pun out of it. It doesn't really work though. Like modern times call for modern actions. I don't know. It doesn't really like have a ring to it. So I'm gonna pretend I didn't just say that. I didn't just say modern times have or call. I didn't say modern times call for modern actions. I have to stop stalling and replace this shit. But in modern times, everybody has this thing called excuses or a subclause or I don't know. It's like a situation, a mess, whatever. So at least inside this documentation, they acknowledge that leaking memory is an issue, but instead of offering a solution or fixing the standard, which is broken because if circular references exist, that's broken. So instead of like saying our documentation is broken, the new documentation, they say there are mechanisms that can be used to stop leaking memory resources, and then they source to mechanisms here and here. So they're like, we know we can't cook, but these guys cooked up some PDFs and it might be a solution, but it doesn't really fit. So go cook your own recipe, get cooking, because I don't know, these guys aren't cooking apparently. Maybe back in 2009 they could cook, but like once your documentation says leaks are acceptable, you're no longer a chef. I don't know, whatever. So I'm gonna like restart this modern computer because something's wrong with Siri. It's not working. It has been on this computer for maybe like 22 hours, but that's no excuse because the modern operating system would be stable after being designed for many years. You'd think like they'd fix things, but that's not how the modern operating system is, I guess. I love saying the word modern. Modern. So I'm going to do a modern restart here. Click on this modern X and this other modern X to close the window. this is a modern browser on a modern website. I'm going to close it in a modern manner. Not like, I don't know what's going to go on. The sound won't, I don't know what will happen with the sound because I'm passing the sound in and then out or whatever. I don't know. So I'm going to restart this computer. I'm going to back up this stuff. I'm going to open Siri. I'll get it to read the standard and then I'm going to replace Notepad doesn't work. I'm going to go through and replace whenever it gets up to the top. Did it not save? I don't think it saved since the last time I closed it. I thought it would have saved. It saved other times, but not this time. I don't know. There's like, is it 3,000? There's a couple thousand of hints or whatever. I'm gonna replace them with oh, this program does not work. I'm gonna replace them with this. So that's the plan. And then tomorrow I'm gonna have to find a couple places where it's not really a comment and rename it back to this. And that'll be fixed. I'm doing that tomorrow though. I'm gonna get the ints right now. I'm gonna get this over with and blah blah blah. I'm gonna restart and yeah. So first, saving back up. I want to say modern, but it's kind of getting old, so I'm not gonna say modern and then just stop talking for a bit. It looks like this built or ran after it built. Check the output. This computer is so laggy, I might need to restart it. It looks the same, so I think it's okay. But this is running on the modern operating system, so if everything's actually okay, I can't be sure. I'm not totally certain because this all runs on the modern OS, so I think it's okay, but not absolutely certain. I hope it's okay. I'm gonna save it back up, whatever. copying. It's slow. I should have restarted the Mac. Oh, I can't hear now. I'm gonna do a modern restart. Testing. I got the hiccups. I'm probably dying. I'm probably gonna die. I got the hiccups. I don't know, it's weird. I had the hiccups a couple days ago. I think it's a sign of sleep deprivation, but probably not. I probably just need more water. What I need to do is replace these ends right now and get done with this shit. So I'm gonna open up the modern browser. I'm gonna go to YouTube and play it might be ancient, however old this song is, whatever. I'm gonna play one song on repeat. I'm gonna try to focus and replace a couple grains of sand. I have to like 3,000 grains of sand. I don't know. It might have been 5,000. I can't remember. I don't remember because I forgot. I'm like, crap, I don't want to remember how many that is. So I'm gonna find a song, play it on loop, and then I can get Siri reading this thing. I'm gonna replace this shit, and I'm gonna run it. I have it back up. The compiler's open, so I'm gonna replace, run. And tomorrow I have some cleanup work to do with the comment tag and I do have to do a mass replace on all the unsigned ints that I didn't tag as comment. I'll do that after, though, I fix whatever spots where it's tagged as comment, but it's not a comment. So I'm gonna play song on loop, focus, get this done now. That's the plan, at least. I don't know how it's gonna go. This modern operating system could go down at any time. Just, it's down. Blue screen. It's over. Until I reboot, and then I waste time trying to figure out what happened. Like, what the modern happened. How could this even happen? I don't know. I'm done stalling. And this is so... I hate this. This takes forever. What's that cover where they're like, it's one for the money? Like, yeah, I don't know the band. Is it one for the show? I thought it was Sleeping Sirens. Dang it, I gotta look this up. I just want to play one song on loop. If I can't find the song, it's gonna ruin my mood. I'm not gonna want to do this. Oh, it's Escape the Fate, not Sleeping with Sirens. They're like the same thing, but okay. They're not the same thing at all. But what is the same is a modern operating system. Modern. so I'm gonna just place on loop and replace the rest of these. How many? I think there's like 1,000 less than the 6,300 total. Okay, so there's oh, this was the number last time. So I'm gonna look through 6,000, this many, whatever, and only replace this many. Because some of them are like, they're not int, they're like print or the word point or whatever. And then I'm done with the stream, and I'm hoping the compiler will build as long as I don't mess anything up. I might make a mistake or two, who knows. Whatever.
slot called whose value is either an object or the null value. This object is called the proxy's target object. An object is a proxy exotic object if its essential internal methods, including and, if applicable, use the definitions in this section. These internal methods are installed in proxy create, table 34. Proxy handler methods. Internal method. Handler method. Get prototype of set prototype of is extensible prevent extensions get own property descriptor define own property has get set delete property own keys call apply construct when a handler method is called to provide the implementation of a proxy object internal method, the handler method is passed the proxy's target object as a parameter. A proxy's handler object does not necessarily have a method corresponding to every essential internal method. Invoking an internal method on the proxy results in the invocation of the corresponding internal method on the proxy's target object if the handler object does not have a method corresponding to the internal trap. The internal slots of a proxy object are always initialized when the object is created and typically may not be modified. Some proxy objects are created in a manner that permits them to be subsequently revoked. When a proxy is revoked, its internal slots are set to null, causing subsequent invocations of internal methods on that proxy object to throw a type error exception. Because proxy objects permit the implementation of internal methods to be provided by arbitrary ECMAScript code, it is possible to define a proxy object whose handler methods violates the invariants defined in 6.1.7.3. Some of the internal method invariants defined in 6.1.7.3 are essential integrity invariants. These invariants are explicitly enforced by the proxy object internal methods specified in this section. An ECMAScript implementation must be robust in the presence of all possible invariant violations. In the following algorithm descriptions, assume O is an ECMAScript proxy object, P is a property key value, V is any ECMAScript language value, and desc is a property descriptor record. O for copyright sign, ECMA International 2024 1051. The internal method of a proxy exotic object O takes no arguments and returns either a normal completion containing either an object or null, or a throw completion. It performs the following steps when called. Perform. Validate non-revoked proxy. O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Get prototype of. If trap is undefined, then a return target. EOF. Let handler prota be. Call. Trap. Handler. Target. If handler prota is not an object and handler prota is not null, throw a type error exception. Let extensible target be. Is extensible target 0. If extensible target is true, return handler prota 1. Let target prota be target 2. If same value, handler prota, target prota, is false, throw a type error exception 3. Return handler prota 0, 5, 2. V. The internal method of a proxy exotic object O takes argument V, an object or null, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Perform. Validate non-revoked proxy O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Set prototype of. If trap is undefined, then a return target. V. Let boolean trap result be to boolean. Call. Trap. Handler. Target. V. If boolean trap result is false, return false. Let extensible target be. Is extensible target 0. If extensible target is true, return true 1. Let target prota be target 2. If same value, V, target prota, is false, throw a type error exception 3. Return true. Note for proxy objects enforces the following invariants. The result of must be either an object or null if the target object is not extensible. applied to the proxy object must return the same value as applied to the proxy object's target object. Note: for proxy objects enforces the following invariance. The result of is a Boolean value. If the target object is not extensible, the argument value must be the same as the result of get prototype of applied to target object. ECMA International 2024 205 1053. The internal method of a proxy exotic object O takes no arguments and returns either a normal completion containing a Boolean or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler is extensible. If trap is undefined, then a return is extensible. Target. Let Boolean trap result be to Boolean. Call. Trap. Handler. Target. Let target result be is extensible. Target. If Boolean trap result is not target result, throw a type error exception 0. Return Boolean trap result 0, 5, 4. The internal method of a proxy exotic object O takes no arguments and returns either a normal completion containing a Boolean or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Prevent extensions. If trap is undefined, then a return target. Let Boolean trap result be to Boolean. Call. Trap. Handler. Target. If Boolean trap result is true, then a let extensible target be is extensible. Target. B. If extensible target is true, throw a type error exception. Return Boolean trap result 0, 5, 5. P. The internal method of a proxy exotic object O takes argument P, a property key, and returns either a normal completion containing either a property descriptor or undefined, or a throw completion. It performs the following steps when called. Note: for proxy objects enforces the following invariance. The result of is a Boolean value. Applied to the proxy object must return the same value as applied to the proxy object's target object with the same argument. Note: for proxy objects enforces the following invariance. The result of is a Boolean value. Applied to the proxy object only returns true if applied to the proxy object's target object is false. 2. Perform. Validate non-revoke proxy O. Let target be O. 06. ECMA International 2024. 3. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Get own property descriptor. If trap is undefined, then a return target. P. Let trap result obj be. Call. Trap. Handler. Target. P. If trap result obj is not an object and trap result obj is not undefined, throw a type error exception. Let target desk be target. P. 0. If trap result obj is undefined, then if target desk is undefined, return undefined. B. If target desk is false, throw a type error exception. C. Let extensible target be is extensible. Target. D. If extensible target is false, throw a type error exception. E. Return undefined. 1. Let extensible target be is extensible. Target. 2. Let result desk be to property descriptor. Trap result obj. 3. Perform complete property descriptor. Result desk. 4. Let valid be as compatible property descriptor. Extensible target. Result desk. Target desk. 5. If valid is false, throw a type error exception. 6. If result desk is false, then if target desk is undefined or target desk is true, then I throw a type error exception. B. If result desk has a field and result desk is false, then I assert target desk has a field. 2. If target desk is true, throw a type error exception. 7. Return result desk. Note: for prox Y objects enforces the following invariance. The result of must be either an object or undefined. A property cannot be reported as non-existent if it exists as a non-configurable own property of the target object. A property cannot be reported as non-existent if it exists as a known property of a non-extensible target object. A property cannot be reported as existent if it does not exist as an own property of the target object and the target object is not extensible. A property cannot be reported as non-configurable unless it exists as a non-configurable own property of the target object. A property cannot be reported as both non-configurable and non-writable unless it exists as a non-configurable, non-writable own property of the target object. 0, 5, 6, p, desc. The internal method of a proxy exotic object O takes arguments p, a property key, and desc, a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy. O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Define property. If trap is undefined, then a return target. P. Desc. Let desc obj be from property descriptor. Desc. Let boolean trap result be to boolean. Call. Trap. Handler. Target. P. Desc obj. If boolean trap result is false, return false. 0. Let target desc be target. P. ECMA International 2024 207. 11. Let extensible target be. Is extensible. Target. 2. If desc has a field and desc is false, then a let setting config false be true. 13. Else a let setting config false be false. 4. If target desc is undefined, then A if extensible target is false, throw a type error exception. B if setting config false is true, throw a type error exception. 5. Else A if is compatible property descriptor, extensible target, target desc, is false, throw a type error exception. B if setting config false is true and target desc is true, throw a type error exception. C if is data descriptor, target desc, is true, target desc is false, and target desc is true. Then, I if desc has a field and desc is false, throw a type error exception. 6. Return true. Note for proxy objects enforces the following invariants. The result of is a boolean value. A property cannot be added if the target object is not extensible. A property cannot be non-configurable unless there exists a corresponding non-configurable own property of the target object. A non-configurable property cannot be non-writable unless there exists a corresponding non-configurable, non-writable own p property of the target object. If a property has a corresponding target object property, then applying the property descriptor of the property to the target object using will not throw an exception. 0, 5, 7, p. The internal method of a proxy exotic object O takes argument p, a property key, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy. O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler has. If trap is undefined, then a return target. P. Let boolean trap.
I think the compiler just fucked me. It might be one of those 30% chances where the compiler does whatever the fuck the compiler wants to do. I did hit save on a couple files on accident because I was like, I'll just save it. And that could have messed up the compiler. The modern compiler. Pressing save on a file messed up the modern compiler because I hit save when the modern compiler was running. And the modern compiler, I guess it's not able to run correctly if a file's opened and modified while it's building a project. The modern compiler. So I'm gonna undo what I did and then try to build it again. But I can't save the files, I don't think, because they're not saving when I hit save now. I don't know. This is annoying.
Target desk 0. Return trap result. Note: the value reported for a property must be the same as the value of the corresponding target object property if the target object property is a non-writable.
The modern operating system should have some way to manage files so that a file can't be saved at the same time. If it can, they should come up with, like, maybe give the old program an old copy, maybe the new program or the other program using it, maybe that program modifies like a shadow copy of it and it doesn't get applied until the other program has finished using it, and then it could alert the other program that there was a change. That would seem like a modern, well, I don't know what modern means. Apparently, I guess we live in the 1970s or something.
24209. If is data descriptor target desk is true and target desk is false, then I have same value. V target desk is false. Throw a type error exception. B if is access.
So I'm gonna undo everything.
1. Return true. Note: the result of cannot change the value of a property to be different from the value of the corresponding target object property if the corresponding target object.
It's really laggy, this computer.
Own data property cannot set the value of a property if the corresponding target object property is a non-configurable own accessor property that has undefined as its 0510 P. The internal method of a proxy exotic object O takes argument P, a property key, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Perform. Validate non-revoked proxy O. Let target be O. Let handler be O. Assert. Let trap.
Okay, so it looks like the main file saved here.
Return target P. Let boolean trap result be to boolean. Call trap handler target.
But it won't save here.
Target desk be target P 0. If target desk is undefined, return true. 1. If target desk is
So I hit save, whatever.
type error exception. 2. Let
Oh, it's saved. That's great. Out saving. It didn't give the warning. Maybe everything will be okay.
4. Return true. Note: for proxy objects enforces the following.
Or maybe it won't.
A property cannot be reported as deleted if it exists as a non-configurable own property of the target object. A property cannot be reported as deleted if it exists as a known property of the target object and the target object is non-extensible. 0511. The internal method of a proxy exotic object O take.
I think I'll stop with stalling and just do this.
Target BO. Let handler BO. Assert.
Like modern problems call for modern solutions, so use Microsoft solutions.
Return target. Let trap result or AB. Call.
Because Microsoft has a modern fix for all your ancient problems. See, they have they call it a solution right there. They got the answers. Microsoft.
Assert. Target keys.
They should make that their slogan.
Contains no duplicate entry.
Well, their slogan should be "We suck dick." That should be Microsoft's slogan. And also "We don't know how to make a cell phone." That should also be their slogan. Their slogan should be We can spend $7 billion, buy 3 cell phone companies, and fail to compete in the cell phone market. And we suck dicks. That should be Microsoft's slogan. Like, for real. For real, for real. Like, as real as it gets, that should be the slogan. Okay, no, actually, that's kind of crude. Their slogan should be, how the fuck are we in business? That should be Microsoft's slogan.
Remove key from unchecked result keys. 2. If unchecked result keys is not...
And they could have a commercial. They could show like the Windows Surface laptop. And they could be like, Microsoft, how the fuck are we in business? Like a little glimmer sound. I think it'd be catchy, you know. I don't know, I think that's a good slogan.
Configurable own properties of the target object. If the target object is not extensible, then the result list must contain all the keys of the own properties of the target object and no other values. 0, 5, 1, 2. This arguments list. The internal method of a proxy exotic object O takes arguments. This argument, an ECMAScript language, var, lu, and arguments list, a list of ECMAScript language.
Or it could be Windows featuring problems. Don't worry, we have a solution. I don't know, it's kind of catchy.
Handler BO, assert. Handler is an object. Let trap be. Get method. Handler. Apply. If trap is undefined, then a return.
The real solution would be to use a Linux or Linux, like Ubuntu or Apple. Apple's like dying, so I don't know. I don't think these companies are whatever.
International 2024 211, the 10th of May 2013. Arguments list. New target. The internal method of a proxy exotic object O takes arguments list, a list of ECMAScript language values, a new target, a constructor, and
like, I don't think Apple could die any slower. They're just like
let target BO assert is constructor, target is true. Let handler BO assert. Handler is an object.
Especially with the AI stuff, they're getting sued for lying about making commercials, like presenting things that Siri or whatever doesn't even do. And people bought their Apple products thinking it doesn't matter if they thought it was a lie, and they're getting sued on it. I don't know, Apple hit a real low.
An object 0, 5, 1.
I think they might be worse than Microsoft at this point.
Evoke proxy takes argument proxy, a proxy exotic object, and returns either a normal completion container.
But they're both just so bad that they're like 2 peas in a pod. I don't know. They're a couple beans.
Proxy is null. Throw a type error exception. Assert. Proxy is not null. Return unused. 0, 5, 1.
I'm like so annoyed. I just want to be done. I want to finish up one thing today and then be like, it's done. I did that big chunk of shit. Next chunk of shit to do after that, get that done. But no, I can't get that. Always to some technicality. Freaking ends. I don't know why I used int. I should have always used signed or unsigned.
Type error exception. Let P be make basic object. Set P's essential internal methods, except friend, to the definitions specified in 10.5. If is callable, target is true, then A set P is specified in the 10th of May 2012. B if is constructor, target is true, Then, I set P as specified in the 10th of May 2013. Set P to target. Set P to handler. Return P, 12. ECMA International.
I think I replaced the main file. I hit save. And I replaced the keyword int with this new token, keyword whatever, defined inside the main as it was building, because I don't know, I realized that main's open in this window, and I did hit save, and I was clicking through and replacing stuff. I'm not totally reading, I'm just checking if there's a space before and after the word int. So that could have been what happened. It probably is what happened. But it doesn't matter, because a modern operating system would be able to go, oh, we're going to make a copy of the file, or oh, you can't save the file until we're done with it. Or no, that's not modern, I guess, I don't know. Okay, so this time I'm not going to hit save when it's building at all. I'm going to have to like wait 2 minutes for it to build. That's why I hit save. I hate waiting. 2 minutes is a very long time. 2 minutes is longer or shorter than the time I just wasted complaining.
Such an escape sequence is effectively ignored as part of the comment. ECMAScript differs from the Java programming language in the behavior of Unicode escape sequence.
I think if I complain enough, I'll actually get tired of complaining, because it is getting tiring to complain.
It is a line terminator. Unicode code point U plus 000A is line.
This computer's so laggy, I can't even tell. Like,
if the Unicode escape sequence U000A occurs within a string literal in a Java program, it is likewise interpreted as a line terminator.
so I undid everything, whatever. So I'm gonna run it again.
0.
It's gonna take 2 minutes. I'm gonna clean the solution. Place clean. Build. Just please fucking build. Okay, so far so good. If I sit here for 2 minutes, I'm gonna fall asleep. I'm gonna go find some food to eat and walk. Cause I can't. If I sit here doing nothing, I'm gonna fall asleep. I'm gonna replace these before I sleep. I'll be back.
String. It performs the following steps when called. Assert. 0CP0 times 10FF. If CP0XFF. Return the string value consisting of the code unit whose numeric value is CP. Let C1 be the code unit whose numeric value is floor. CP0 times 10,000. 0 times 400 plus 0xd800. Let Q2 be the code unit whose numeric value is CP0 times 10,000. Modulo 0 times 400 plus 0xdc00. Return the string concatenation of Q1 and Q2. ECMA International 2024-213. 1 2 static semantics. Code points to string. Text. The abstract operation code points to string takes argument text, a sequence of Unicode code points, and returns a string. It converts text into a string value, as described in 6.1.4. It performs the following steps when called. Let result be the empty string. For each code point CP of text, do a set result to the string concatenation of result and UTF-16 encode code point CP3. Return result 1 3 static semantics. UTF-16 surrogate pair to code point led trail. The abstract operation UTF-16 surrogate pair to code point takes arguments led a code unit and trail a code unit and returns a code point. Two code units that form a UTF-16 surrogate pair are converted to a code point. It performs the following steps when called. Assert Lead is a leading surrogate and trail is a trailing surrogate. Let CP be lead 0xd800. 0 times 400 plus trail 0xdc00 plus 0 times 10,000. Return the code point CP 1 1. For static semantics, code point at string position. The abstract operation code pointer takes argument string, a string, and position, a non-negative integer, and returns a record with fields, a code point, a positive integer, and a boolean. It interprets string as a sequence of UTF-16 encoded code points, as described in 6.1.4, and reads from it a single code point starting with the code unit at index position. It performs the following steps when called. Let size be the length of string. Assert position 0 and position size. Let first be the code unit at index position within string. Let CP be the code point whose numeric value is the numeric value of first. If a first is neither a leading surrogate nor a trailing surrogate, then return the record CP 1 full 6. If a first is a trailing surrogate or position plus 1 equals size, then return the record CP 1 true. Let second be the code unit at index position plus 1 within string. If second is not a trailing surrogate, then return the record CP 1 true. Set CP to UTF-16 surrogate pair to code point first, second 0. Return the record CP 2 false 1 1. 5 static semantics. String to code points. String. The abstract operation string to code points takes argument string, a string, and returns a list of code points. It returns the sequence of Unicode code points that results from interpreting string as UTF-16 encoded Unicode text as described in 6.1.4. It performs the following steps when called. Let code points be a new empty list. Let size be the length of string. Let position be 0. Repeat. While position, size. Let CP be code point at string, position. Be append CP to code points. Set position to position plus CP. Return code points. 14. ECMA International 2024. 1.1.1. 6 static semantics. Parse text. Source text, goal symbol. The abstract operation parse text takes argument source text, a sequence of Unicode code points, and goal symbol, a non-terminal in one of the ECMAScript grammars, and returns a parse node or a non-empty list of syntax error objects. It performs the following steps when called. Attempt to parse source text using goal symbol as the goal symbol, and analyze the parse result for any early error conditions. Parsing and early error detection may be interleaved in an implementation-defined manner. If the parse succeeded and no early errors were found, return the parse node, an instance of goal symbol, at the root of the parse tree resulting from the parse. Otherwise, return a list of one or more syntax error objects representing the parsing errors and/or early errors. If more than one parsing error or early error is present, the number and ordering of error objects in the list is implementation-defined, but at least one must be present. Note to see also clause 17. 1.2 Types of source code. There are 4 types of ECMAScript code. Global code is source text that is treated as an ECMAScript script. The global code of a particular script does not include any source text that is parsed as part of a function declaration, function expression, generator declaration, generator expression, async function declaration, async function expression, async generator declaration, async generator expression, method definition, arrow function, async arrow function, class declaration, or class expression. Eval code is the source text supplied to the built-in eval function. More precisely, if the parameter to the built-in eval function is a string, it is treated as an ECMAScript script. The eval code for a particular invocation of eval is the global code portion of that script. Function code is source text that is parsed to supply the value of the and internal slots, see 10.2, of an ECMAScript function object. The function code of a particular ECMAScript function does not include any source text that is parsed as the function code of a nested function declaration, function expression, generator declaration, generator expression, async function declaration, async function expression, async generator declaration, async generator expression, method definition, arrow function, async arrow function, class declaration or class expression. In addition, if the source text referred to above is parsed as the formal parameters and function body of a function declaration or function expression, the formal parameters and generator body of a generator declaration or generator expression, the formal parameters and async function body of an async function declaration or async function expression, or the formal parameters and async generator body of an async generator declaration or async generator expression, then the source text matched by the binding identifier, if any of that declaration or expression is also included in the function code of the corresponding function. Module code is source text that is code that is provided as a module body. It is the code that is directly evaluated when a module is initialized. The module code of a particular module does not include any source. Note 1. Consider a text that has an early error at a particular point, and also a syntax error at a later point. An implementation that does a parse pass followed by an early errors pass might report the syntax error and not proceed to the early errors pass. An implementation that interleaves the two activities might report the early error and not proceed to find the syntax error. A third implementation might report both errors. All of these behaviors are conformant. Copyright sign, ECMA International 2024 215. Text that is parsed as part of a nested function declaration, function expression, generator declaration, generator expression, async function declaration, async function expression.
It looks like it works, so... Water. Okay, so I'm gonna try this again, and I'm gonna turn off the compiler. I'm gonna close it, just to make sure it's not running after it's done.
Arrow functions, 15.9. Function code is also derived from the arguments to the function constructor, 2021.
The compiler could still be running realistically on the modern operating system, but I'm gonna assume it closed and it's all good.
Finding identifier in function code.
So I'm gonna Control Shift F, Control Shift F, and then find int. I'm gonna find int with the space first, like a space before and after int, so it's easier, and then I'll look through int with the space after, not before, and I'll get those. So I'm gonna get the easy ones and then the other ones, and then I'm done for now.
Automatic semicolon insertion, 12.10. A directive prologue may be an empty sequence.
So I'm gonna cue the music on loop, find and replace, and I don't know.
Strict directive may not contain an escape sequence or line continuation. A directive prologue may contain more than one use strict directive.
If the mouse will even switch over to the computer. One for the money.
Syntax and semantics.
Do it for the show.
Code is interpreted as strict mode code in the following situations. Global code is class declaration or a class expression a strict mode code. Eval code is strict mode code if it begins with a directive prologue that contains a use.
This button is broken.
Is contained in strict mode code. Function code is strict mode code if the associated function declaration, function expression, generator declaration, generator expression, async function declaration, async function expression, async generator declaration, async generator expression, method definition, arrow function. or async arrow function is contained in strict mode code, or if the code that produces the value of the function's internal slot begins with a directive prologue that contains a use strict directive function code that is supplied as the arguments to the built-in function generator async function. And async generator constructors is strict mode code if the last argument is a string that, when processed, is a function body that begins with a directive prologue that contains a use strict directive. ECMAScript code that is not strict mode code is called non-strict code. 16. Copyright sign. ECMA International 2024. Note the expression statements of a directive prologue are evaluated normally during evaluation of the containing production. Implementations may define implementation-specific meanings for expression statements which are not a use-strict directive and which occur in a directive prologue. If an appropriate notification mechanism exists, an implementation should issue a warning if it encounters in a directive prologue an expression statement that is not a use-strict directive and which does not have a meaning defined by the implementation. 1. 2. 3 non-ECMAScript functions. An ECMAScript implementation may support the evaluation of function exotic objects whose evaluative behavior is expressed in some host-defined form of executable code other than ECMAScript source text. Whether a function object is defined within ECMAScript code or as a built-in function is not observable from the perspective of ECMAScript code that calls or is called by such a function object. 2. ECMAScript language. Lexical grammar. The source text of an ECMAScript script or module is first converted into a sequence of input elements, which are tokens, line terminators, comments, or white space. The source text is scanned from left to right, repeatedly taking the longest possible sequence of code points as the next input element. There are several situations where the identification of lexical input elements is sensitive to the syntactic grammar context that is consuming the input elements. This requires multiple goal symbols for the lexical grammar. The input element #bang or regexp goal is used at the start of a script or module. The capital I, N, P, U, T, capital E, L, E, M, E, N, T, capital R, E, G, capital E, X, P, capital O, R, capital T, E, M, P, L, A, T, E, capital T, A. Goal is used in syntactic grammar contexts where a regular expression literal, a template middle, or a template tail is permitted. The input element regexp goal symbol is used in all syntactic grammar contexts where a regular expression literal is permitted but neither a template middle nor a template tail is permitted. The input element template tail goal is used in all syntactic grammar contexts where a template middle or a template tail is permitted but a regular expression literal is not permitted. In all other contexts, input element div is used as the lexical goal symbol. Note the use of multiple lexical goals ensures that there are no lexical ambiguities that would affect automatic semicolon insertion. For example, there are no syntactic grammar contexts where both a leading division or division assignment and a leading regular expression literal are permitted. This is not affected by semicolon insertion, see 12.10, in examples such as the following: a equals b high g exec, cmap, d, where the first non-white space, non-comment code point after a line terminator is u plus 002f, solidus, and the syntactic context allows division or division assignment. No semicolon is inserted at the line terminator. That is, the above example is interpreted in the same way as a equals b high g exec, cmap, d, syntax, input element of white space, line terminator comment token div punctuator right brace punctuator, input element regexp, white space, line terminator comment token right brace punctuator regular expression literal. ECMA International 2024 217, capital I, N, P, U, T, capital E, L, E, M, E, N, T, capital R, E, G, capital E, X, P, capital O, R, capital T, E, M, P, L, A, T, E, capital T, A, white space, line terminator comment token regular expression literal template substitution tail, input element template tail, white space, line terminator comment token div punctuated template substitution tail, input element hashbang or regexp, white space, line terminator comment token hashbang comment regular expression literal 2.1 Unicode format control characters. The Unicode format control characters, that is, the characters in category CF in the Unicode character database such as left to right mark or right to left mark, are control codes used to control the formatting of a range of text in the absence of higher level protocols for this, such as markup languages. It is useful to allow format control characters in source text to facilitate editing and display. All format control characters may be used within COM, ENS, and within string literals, template literals, and regular expression literals. U plus 200C, 0 width non-joiner, and U plus 200D, 0 width joiner, are format control characters that are used to make necessary distinctions when forming words or phrases in certain languages. In ECMAScript source text, these code points may also be used in an identifier name after the first character. U plus F, 0 width no break space, is a format control character used primarily at the start of a text to mark it as Unicode and to allow detection of the text's encoding in byte order. ZWMBSP. Characters intended for this purpose can sometimes also appear after the start of a text. For example, as a result of concatenating files. In ECMAScript source text, ZWMBSP, code points are treated as white space characters. See 12.2. The special treatment of certain format control characters outside of comments, string literals, and regular expression literals is summarized in Table 35. Table 35. Format control code point usage. Code point name abbreviation usage U plus 200C 0 width non-joiner ZWNJ identifier part U plus 200D 0 width joiner ZWJ identifier part U plus FF 0 width no break space ZWNBSP white space 218 ECMA International 2024 12.2 white space code points are used to improve source text readability and to separate tokens, indivisible lexical units, from each other, but are otherwise insignificant. White space code points may occur between any two tokens and at the start or end of input. White space code points may occur within a string literal, a regular expression literal, a template, or a template substitution tail where they are considered significant code points forming part of a literal value. They may also occur within a comment, but cannot appear within any other kind of token. The ECMAScript white space code points are listed in Table 36. Table 36. White space code points. Code points. Name. Abbreviation. U plus 0009. Character tabulation. Tab. U plus 000B. Line tabulation. VT. U plus 000C. Form feed. FF. U plus FF. 0 width no break space. ZWNBSP. Any code point in general category space separator. USP. No 1 U plus 0020. Space. And U plus 00A0. No break space. Code points are part of USP syntax. Note 2. Other than for the code points listed in Table 36, ECMAScript white space intentionally excludes all code points that have the Unicode white space property but which are not classified in general category space separator. ZEDS 2.3 white space tab VT FF ZWMBSP USP line terminators like white space code points. Line terminator code points are used to improve source text readability and to separate tokens, indivisible lexical units, from each other. However, unlike white space code points, line terminators have some influence over the behavior of the syntactic grammar. In general, line terminators may occur between any two tokens, but there are a few places where they are forbidden by the syntactic grammar. Line terminators also affect the process of automatic semicolon insertion. 12.10. A line terminator cannot occur within any token except a string literal, template, or template substitution tail, LF. and CR line terminators cannot occur within a string literal token except as part of a line continuation. A line terminator can occur within a multi-line comment but cannot occur within a single line comment. Line terminators are included in the set of white space code points that are matched by the S-class in regular expressions. ECMA International 2024-219. The ECMAScript line terminator code points are listed in Table 37. Table 37. Line terminator code points. Code point. Unicode name. Abbreviation. U plus 000. Line feed. LF. U plus 000. D. Carriage return CR. U plus 2028. Line separator. LS. U plus 2029. Paragraph separator. PS. Only the Unicode code points in Table 37 are treated as line terminators. Other new line or line breaking Unicode code points are not treated as line terminators but are treated as white space if they meet the requirements listed in Table 36. The sequence CR, LF is commonly used as a line terminator. It should be considered a single source character for the purpose of reporting line numbers. Syntax: line terminator, LF, CRLS, PS, line terminator sequence, LF, CR look ahead, LF, LS, PS, CRLF. 2.4 comments. Comments can be either single or multi-line. Multi-line comments cannot nest, because a single line comment can contain any Unicode code point except a line terminator code point, and because of the general rule that a token is always as long as possible. A single line comment always consists of all code points from the marker to the end of the line. However, the line terminator at the end of the line is not considered to be part of the single line comment. It is recognized separately by the lexical grammar and becomes part of the stream of input elements for the syntactic grammar. This point is very important because it implies that the presence or absence of single line comments does not affect the process of automatic semicolon insertion. See 12.10. Comments behave like white space and are discarded except that if a multi-line comment contains a line terminator code point, then the entire comment is considered to be a line terminator for purposes of parsing by the syntactic grammar. Syntax: comment, multi-line comment, single line comment. 20. ECMA International 2024. Multi-line comment charsopt, multi-line comment chars, multi-line not asterisk char, multi-line comment charsopt, post asterisk comment charsopt, post asterisk comment chars. Capital M U L T I, capital L I N E, capital N O T, capital F O R W A R D, capital S L A S H, capital O R, capital A S T E, multi-line comment charsopt, post asterisk comment charsopt, multi-line not asterisk char, source character but not, capital M U L T I, capital L I N E, capital N O T, capital F O R W A R D, capital S L A S H, capital O R, capital A S T E, source character but not one of all, single line comment charsopt, single line comment chars, single line comment char, single line comment charsopt, single line comment char, source character but not line terminator. A number of productions in this section are given alternative definitions in section B. 1.112.5 Hashbang comments. Hashbang comments are location sensitive and like other types of comments are discarded from the stream of input elements for the syntactic grammar. Syntax: hashbang comment, single line comment charsopt. 2.6 Tokens syntax: common token, identifier name, private identifier, punctuator, numeric literal, string literal, template. Note the div punctuator, regular expression literal, right brace punctuator, and template substitution. Tail productions derive additional tokens that are not included in the common token production. ECMA International 2024 221. 12.7 Names and keywords. Identifier name and reserved word are tokens that are interpreted according to the default identifier syntax given in Unicode Standard Annex number 31. Identifier and pattern syntax, with some small modifications. Reserved word is an enumerated subset of identifier name. The syntactic grammar defines identifier as an identifier name that is not a reserved word. The Unicode identifier grammar is based on character properties specified by the Unicode standard. The Unicode code points and the specified categories in the latest version of the Unicode standard must be treated as in those categories by all conforming ECMAScript implementations. ECMAScript implementations may recognize identifier code points defined in later editions of the Unicode standard. Syntax: private identifier, identifier name, identifier name, identifier start, identifier name, identifier part, identifier start, identifier start char, Unicode escape sequence, identifier part, identifier part char, Unicode escape sequence, identifier start char, Unicode ID start, underscore, identifier part char, Unicode ID continue, ZWNJ, ZWJ, assign letter, one of A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z, capital A, capital B, capital C, capital D, not but Gustav X's. Unicode ID start. Any Unicode code point with the Unicode property ID start. Unicode ID continue. Any Unicode code point with the Unicode property ID continue. The definitions of the non-terminal Unicode escape sequences given in 1.2.9.4. Note 1. This standard specifies specific code point additions U+0024 $, and U+005F low line are permitted anywhere in an identifier name, and the code points U+200C 0 width non-joiner and U+200D 0 width joiner are permitted anywhere after the first code point of an identifier name. 22. Copyright sign. ECMA International 2024. Note 2. The non-terminal identifier part derives via Unicode ID continue. 2. 7. 1. Identifier names. Unicode escape sequences are permitted in an identifier name, where they contribute a single Unicode code point equal to the identifier code point of the Unicode escape sequence. The preceding the Unicode escape sequence does not contribute any code points. A Unicode escape sequence cannot be used to contribute a code point to an identifier name that would otherwise be invalid. In other words, if a Unicode escape sequence were replaced by the source character it contributes, the result must still be a valid identifier name that has the exact same sequence of source character elements as the original identifier name. All interpretations of identifier name within this specification are based upon their actual code points regardless of whether or not an escape sequence was used to contribute any particular code point. 2. Identifier names that are canonically equivalent according to the Unicode standard are not equal unless, after replacement of each Unicode escape sequence, they are represented by the exact same sequence of code points. 2. 7. 1. 1. Static semantics. Early errors. Identifier start. Unicode escape sequence. It is a syntax error if identifier code point of Unicode escape sequence is not some Unicode code point matched by the identifier start char lexical grammar production. Identifier part. Unicode escape sequence. It is a syntax error if identifier code point of Unicode escape sequence is not some Unicode code point matched by the identifier part char lexical grammar production. 2. 7. 1. 2. Static semantics. Identifier code points. The syntax-directed operation identifier code points takes no arguments and returns a list of code points. It is defined piecewise over the following productions. Identifier name. Identifier start. Let CP be identifier code point of identifier start. Return CP. Identifier name. Identifier name identifier part. Let CPS be identifier code points of the derived identifier name. Let CP be identifier code point of identifier part. Return the list concatenation of CPS and CP. 2, 7, 1. 3 static semantics. Identifier code point. The syntax-directed operation identifier code point takes no arguments and returns a code point. It is defined piecewise over the following productions. Identifier start. Identifier start char. Return the code point matched by identifier start char. Note 3. The sets of code points with Unicode properties ID start and ID continue include, respectively, the code points with Unicode properties other ID start and other ID continue. ECMA International 2024 223. Identifier part. Identifier part char. Return the code point matched by identifier part char. Unicode escape sequence. U hex 4 digits. Return the code point whose numeric value is the NV of hex 4 digits. Unicode escape sequence. U code point. Return the code point whose numeric value is the NV of code point. 2, 7. 2 keywords and reserved words. A keyword is a token that matches identifier name, but also has a syntactic use. That is, it appears literally, in a fixed width font, in some syntactic production. The keywords of ECMAScript include if, while, async, await, and many others. A reserved word is an identifier name that cannot be used as an identifier. Many keywords are reserved words, but some are not, and some are served only in certain contexts. If and while a reserved word's await is reserved only inside async functions and modules, async is not reserved. It can be used as a variable name or statement label without restriction. This specification uses a combination of grammatical productions and early error rules to specify which names are valid identifiers and which are reserved words. All tokens in the reserved word list below, except for await and yield, are unconditionally reserved. Exceptions for await and yield are specified in 13.1, using parameterized syntactic productions. Lastly, several early error rules restrict the set of valid identifiers. C13, 1, 1, 1, 4, 3, 1, 1, 1, 4, 7, 5, 1, and 1, 5, 7, 1. In summary, there are 5 categories of identifier names. Those that are always allowed as identifiers, and are not keywords, such as math, window, to string, and those that are never allowed as identifiers, namely the reserved words listed below except await and yield. Those that are contextually allowed as identifiers, namely await and yield. Those that are contextually disallowed as identifiers, in strict mode code. Let, static, implements, interface, package, private, protected, and public. Those that are always allowed as identifiers, but also appear as keywords within certain syntactic productions, at places where identifier is not allowed, as async, from, get, meta, of, set, and target. The term conditional keyword, or contextual keyword, is sometimes used to refer to the keywords that fall in the last 3 categories, and thus can be used as identifiers in some contexts and as keywords in others. Syntax. Reserved word. 1 of await break case catch class const continue debugger default delete do else enum export extends false finally for function of import an instantiate new null return super switch this throw true try type of var void well with a yield 24 ECMA International 2024 note 1 per 5 1 5 keywords and the grammar match literal sequences of specific source character elements. A code point and a keyword cannot be expressed by a Unicode escape sequence. An identifier name can contain Unicode escape sequences, but it is not possible to declare a variable named else by spelling it else u. 65. The early error rules in 1.3.1. 1 rule out identifiers with the same string value as a reserved word. Note 2 enum is not currently used as a keyword in this specification. It is a future reserved word, set aside for use as a keyword in future language extensions. Similarly, implements, interface, package, private, protected, and public are future reserved words in strict mode code. Note 3 the names arguments and eval are not keywords, but they are subject to some restrictions in strict mode code. C13, 1, 1, 8, 6, 4, 1, 5, 2, 1, 1, 5, 5, 1, 1, 5, 6, 1, and 1, 5, 8, 1. 2.8 punctuators syntax. Punctuator. Optional chaining punctuator. Other punctuator. Optional chaining punctuator. Look ahead decimal digit. Other punctuator. 1 of, comma equals, equals 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 plus, percent plus plus, and equals plus equals 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 percent equals 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 and equals 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 and equals 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 equals. Div punctuator equals sign. Right brace punctuator 2.9 literals 2 9 1 null literals syntax. Null literal null. ECMA International 2024 225 1 2 9 2 Boolean literals syntax. Boolean literal true false 2 9 3 numeric literals syntax. Numeric literal separator. Numeric literal decimal literal. Decimal big integer literal non-decimal integer literal plus sep. Non-decimal integer literal plus sep. Begin literal suffix legacy octal integer literal. Decimal big integer literal. 0 big int literal suffix. Non-zero digit decimal digits. Plus sep opt begin literal suffix. Non-zero digit numeric literal separator decimal digits. Plus sep. Begin literal suffix. Non-decimal integer literal. Sep. Binary integer literal sep. Octal integer literal sep. Hex integer literal sep. Begin literal suffix. N. Decimal literal. Decimal integer literal. Decimal digits. Plus sep opt exponent part. Plus sep opt. Decimal digits. Plus sep. Exponent part. Plus sep opt. Decimal integer literal exponent part. Plus sep opt. Decimal integer literal. 0 non-zero digit. Non-zero digit numeric literal separator opt decimal digits. Plus sep. Non-octal decimal integer literal. Decimal digits. Sep. Decimal digit. Decimal digit sep. Decimal digit. Plus sep. Decimal digits. Plus sep. Numeric literal separator decimal digit. Decimal digit. 1 of 0 1 2 3 4 5 6 7 8 9 26. ECMA International 2024. Non-zero digit. 1 of 123,456,789. Exponent part. Sep. Exponent indicator signed integer sep. Exponent indicator. 1 of EE. Signed integer. Sep. Decimal digit sep. Decimal digit sep. Decimal digit sep. Binary integer literal. Sep. 0b binary digits sep. 0b binary digits sep. Binary digits. Sep. Binary digit. Binary digits sep. Binary digit. Plus sep. Binary digits. Plus sep. Numeric literal separator binary digit. Binary digit. 1 of 0 1. Octal integer literal. Sep. 0 octal digits sep. 0 octal digits sep. Octal digits. Sep. Octal digit. Octal digit sep. Octal digit. Plus sep. Octal digits. Plus sep. Numeric literal separator octal digit. Legacy octal integer literal. 0 octal digit. Legacy octal integer literal octal digit. Non-octal decimal integer literal. 0 non-octal digit. Capital L E G A C Y. Capital O C T A L. Capital L I K E. Capital D E C I M A L. Capital I N T E G E R. Capital L. Non-octal digit. Non-octal decimal integer literal decimal digit. Capital L E G A C Y. Capital O C T A L. Capital L I K E. Capital D E C I M A L. Capital I N T E G E R. Capital L. 0 octal digit. Capital L E G A C Y. Capital O C T A L, capital L, I, K, E, capital D, E, C, I, M, A, L, capital I, N, T, E, G, E, R, capital L, octal digit, 1 of 1,234,567, non-octal digit, 1 of 89, ECMA International 2024 227, hex integer literal, sep, 0x hex digits sep, 0x hex digits sep, hex digits, sep, hex digit sep, hex digit, plus sep, hex digits, plus sep, numeric literal separator hex digit, 1 of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, abdef A, B, C, D, E, F. The source character immediately following a numeric literal must not be an identifier start or decimal digit. 2, 9, 3, 1 static semantics, early errors, numeric literal, legacy octal, integer literal, decimal integer literal, non-octal decimal integer literal. It is a syntax error if the S or text matched by this production is strict mode code. Note in non-strict code, this syntax is legacy. 2, 9, 3, 2 static semantics, MV, a numeric literal stands for a value of the number type or the big int type. The MV of decimal literal, decimal integer literal. Decimal digits is the MV of decimal integer literal, plus the MV of decimal digits 10n, where n is the number of code points in decimal digits, excluding all occurrences of numeric literal separator. The MV of decimal literal, decimal integer literal. Exponent part is the MV of decimal integer literal. 10e, where e is the MV of exponent part. The MV of decimal literal, decimal integer literal. Decimal digits exponent part is the MV of decimal integer literal plus the MV of decimal digits 10n, 10e, where n is the number of code points in decimal digits, excluding all occurrences of numeric literal separator, and e is the MV of exponent part. The MV of decimal literal. Decimal digits is the MV of decimal digits 10n, where n is the number of code points in decimal digits, excluding all occurrences of numeric literal separator. The MV of decimal literal. Decimal digits exponent part is the MV of decimal digits 10e, n, where n is the number of code points in decimal digits, excluding all occurrences of numeric literal separator, and e is the MV of exponent part. The MV of decimal literal. Decimal integer literal exponent part is the MV of decimal integer literal 10e, where e is the MV of exponent part. The MV of decimal integer literal. 0 is 0. The MV of decimal integer literal, non-zero digit numeric literal separator op decimal digits is the MV of non-zero digit 10n plus the MV of decimal digits, where n is the number of code points in decimal digits, excluding all occurrences of numeric literal separator. The MV of decimal digits. Decimal digit is the MV of decimal digits 10 plus the MV of decimal digit. The MV of decimal digits. Decimal digits numeric literal separator decimal digit is the MV of decimal digits 10 plus the MV of decimal digit. The MV of exponent part. Exponent indicator signed integer is the MV of signed integer. The MV of signed integer. Decimal digits is the negative of the MV of decimal digits. The MV of decimal digit. 0 or of hex digit. 0 or of octal digit. 0 or of 228. ECMA International 2024. Note, for example, 3 inches is an error and not the 2 input elements 3 and in legacy octal escape sequence. 0 or a binary digit. 0 is 0. The MV of decimal digit. 1 or of non-zero digit. 1 or of hex digit. 1 or of octal digit. 1 or of binary digit. 1 is 1. The MV of decimal digit. 2 or of non-zero digit. The MV of decimal digit. 3 or of non-zero digit. The MV of decimal digit. 4 or of non-zero digit. The MV of decimal digit. 5 or of non-zero digit. The MV of decimal digit. 6 or of non-zero digit. The MV of decimal digit. 7 or of non-zero digit. The MV of decimal digit. 8 or of non-zero digit. The MV of decimal digit. 9 or of non-zero digit. Or of hex digit. 2 or of octal digit. 2 is 2, 3 or of hex digit. 3 or of octal digit. 3 is 3, 4 or of hex digit. 4 or of octal digit. 4 is 4, 5 or of hex digit. 5 or of octal digit. 5 is 5, 6 or of hex digit. 6 or of octal digit. 6 is 6, 7 or of hex digit. 7 or of octal digit. 7 is 7, 8 or of non-octal digit. 8 or of hex digit. 8 is or of non-octal digit. 9 or of hex digit. 9 is the MV of hex digit, A or of hex digit. A is 10, the MV of hex digit. B or of hex digit. B is 11, the MV of hex digit. C or of hex digit. C is 12, the MV of hex digit. D or of hex digit. D is 13, the MV of hex digit. E or of hex digit. E is 14, the MV of hex digit. F or of hex digit. F is 15, the MV of binary digits. Binary digit is the MV of binary digits 2 plus the MV of binary digit. The MV of binary digits numeric literal separator binary digit is the MV of binary digits plus the MV of binary digit. The MV of octal digits. Octal digit is the MV of octal digits 8 plus the MV of octal digit. The MV of octal digits. Octal digits numeric literal separator octal digit is the MV of octal digits 8 plus the MV of octal digit. The MV of legacy octal integer literal. Legacy octal integer literal octal digit is the MV of legacy octal integer literal times 8 plus the MV of octal digit. The MV of non-octal decimal integer literal. Capital L, E, G, A, C, Y, capital O, C, T, A, L, capital L, I, K, E, capital D, E, C, I, M, A, L, capital I, N, T, E, G, E, R, capital L, non-octal digit is the MV of capital L, E, G, A, C, Y, capital O, C, T, A, L, capital L, I, K, E, capital D, E, C, I, M, A, L, capital I, N, T, E, G, E, R, capital L, times 10 plus the MV of non-octal digit. The MV of non-octal decimal integer literal. Non-octal decimal integer literal decimal digit is the MV of non-octal decimal integer literal times 10 plus the MV of decimal digit. The MV of capital L, E, G, A, C, Y, capital O, C, T, A, L, capital L, I, K, E, capital D, E, C, I, M, A, L, capital I,
And it's building.
E, R, capital L.
I'll be back in like 10 minutes. This just takes so long to compile.
Capital L, I, K, E, capital D, E, C, I, M, A, L, capital I, N, T, E, G, E, R, capital L, octal digit is the MV of capital L, E, G, A, C, Y, capital O, C, T, A, L, capital L, I, K, E, capital D, E, C, I, M, A, L, capital I, N, T, E, G, E, R, capital L, times 10 plus the MV of octal digit. The MV of hex digits. Hex digit is the MV of hex digits 16 plus the MV of hex digit. The MV of hex digits. Hex digits numeric literal separator hex digit is the MV of hex digits 16 plus the MV of hex digit 2, 9, 3, 3 static semantics. Numeric value. The syntax-directed operation numeric value takes no arguments and returns a number or a big int. It is defined piecewise over the following productions: numeric literal, decimal literal, return round MV result, MV of decimal literal, numeric literal, non-decimal integer literal, return MV of non-decimal integer literal, numeric literal, legacy octal integer literal, return MV of legacy octal integer literal, numeric literal, non-decimal integer literal big int literal suffix, return the big int value for the MV of non-decimal integer literal. ECMA International 2024 229. Decimal big integer literal. 0 big int literal suffix 1. Return 0z. Decimal big integer literal, non-zero digit big int literal suffix 1. Return the big int value E for the MV of non-zero digit decimal big integer literal, non-zero digit decimal digits.
And it looks like it's okay.
Big int lit.
No, I'm not done yet. I have to take one more pass. And then I'm good. And I feel like all that's left is like the couple places where it's not a comment, and then you gotta like do a master place on all the Q tags to replace it with an end tag. And I need some water, so I'm gonna run this, save it back up. One last pass. It's probably like 500 out of 1,800 or something. I don't know. I have to like be careful this time to come through. I don't know, I'm gonna run it, whatever, save it back up. One more pass. Water.
The string. All other code points are encoded as 2 code unit elements of the string. Syntax: string literal, double string character sopt, single string character sopt, double string characters, double string character sopt, single.
I think I used int for arguments. I think that was the reason I used int without the sign or unsigned in front of it. Because like every place where int was at was basically an argument. And I think I did that because typing unsigned and signed in took too much space. So I typed int. I really need some water. Where's me?
Non-octal decimal escape sequence hex escape sequence Unicode escape sequence characteristic.
I don't think I could compete with the previous president that whispered into the microphone, because he was really good at whispering into the microphone to the like citizens of the United States. He'd be like, I don't remember what the last president said. I forgot. I think I have dementia. Yeah. Oh, it's done finally.
Octal digit.
Holy crap, I'm tired.
3, 1 of 0, 1, 2, 3, 4 to 7, 1 of 4,567, non-octal.
Please be it. I want to be done.
Digit. Unicode escape sequence. U hex 4 digits. U. Code point. Hex 4 digits. Hex digit, hex digit, hex digit, hex digit. The definition of the non-terminal hex digit is given in 1, 2, 9, 3. Source character is defined in 11.1. ECMA International 2024 231. Note 2.
I think it's all good.
Except as part of...
I could be more cringe, but I think that's just enough cringe. But I need to stop with the cringe.
0, 2, 9, 4, 1.
Alright, I'm done being cringy. Not really.
Sequence, non-octal decimal.
Alright, I'm gonna save it back up.
Or if the source text.
That's one of the real.
Note 1 in non-strict code. This syntax is legacy 2.9.4 to static semantics. SV, the syntax-directed operation SV takes no arguments and returns a string. A string literal stands for a value of the string type. SV produces string values for string literals through recursive application on the various parts of the string literal. As part of this process, some Unicode code points within the string literal are interpreted as having a mathematical value, as described below or in 1.2.9.3. The SV of string literal is the empty string. The SV of string literal is the empty string. The SV of double string characters is the string. Concatenation of the SV of double string character and the SV of double string characters. The SV of single string characters. Single string character.
So I have it back up. Open the compiler. I don't think the water's helping. And now close all these.
Separator. The SV of double string character.
Shift F. Int space.
SV of double string character. Line continuation is the empty string. The SV of single string character.
Because I did all the space int space first. Because I don't know. There's more of them and
string value consisting of
less chance of messing it up. Now I gotta like check for the word print and point. Make sure I don't pick something that's not an int.
The SV of escape sequence. 0 is the string value consisting of the code unit 0.
That's
For escape sequence. Single escape character is the string value consisting of the code unit whose numeric value is determined by the single escape character according to table 38. Note to it is possible for string literal.
So out of how many left? After this I'm good. I feel like I made progress making up for the other day.
Escape sequence code.
So after this is good. Let's finish.
BS. Zero 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 B line tabulation VT F 0 times 0.
So now I have to search through 2093 matches. And since this is the modern operating system,
Apostrophe.
the modern operating system,
Apostrophe backslash 0 times 0 0.
this notepad is so sucky.
16 encode code point on the code point matched by source character. The SV of escape sequence. Legacy octal escape sequence is the string value consisting of the code unit whose numeric value is the NV of legacy octal.
So now what I have to do is go through 2093 of these. Look for int. I'm looking for int with the space, which means it's going to find things that aren't actually an int, but it will find things that are an int. And a regex is not the solution. So if you think a regex is the answer, you're wrong. Okay, so one more pass and I'm done. I just need to back up, so if I mess it up, I gotta back up. I'm just not gonna mess it up.
View consisting of the code unit 0 times 0 0 0 0 null 1 2 9 4 3 static semantic.
I'm gonna play music again. I need to find a new song. I want to get done more than find a new song, so it'll work.
7 plus the MV of octal digit. The MV of legacy octal escape sequence 0 to 3 octal digit is 64. That is 82 times the MV of 0 to 3 plus 8 times the MV of the first octal digit plus the MV of the second octal digit. The MV of 0 to 3. 0 is 0. The MV of 0
2,000 something ago.
to 3. 2 is 2. The MV of 0 to 3. 3 is 3. The MV of 4 to 7. 4 is 4. The MV of 4 to 7. 5 is 5. The MV of 4 to 7. 6 is 6. The MV of 4 to 7. 7 is 7. The MV of hex escape sequence. X hex digit is 16 times the MV of the first hex digit plus the MV of the second hex digit. The MV of hex 4 digits. Hex digit is 0 times 1000 the MV of the first hex digit, plus 0 times 100 the MV of the second hex digit, plus 0 times 10 the MV of the third hex digit, plus the MV of the fourth hex digit. ECMA International 2024 233 1 2. Scanner to find the end of the regular expression.
I need to make another type. I'm just gonna do these for now and be done. This is like a rabbit hole that'll never end. Well, it will end once I reach the bottom. But I think I'm still like at the very, very top of this rabbit hole. And it's gonna go way down. I'm digging myself into a very deep rabbit hole. So here we go.
Char's regular expression char. Regular expression first char. Regular expression non-terminator but not one of or. Capital R E G U L A R. Capital E X P R E S S I O N. Capital B A C K S L A S H. Capital S E Q U. Regular expression class. Regular expression char. Regular expression non-terminator but not one of or. Capital R E G U L A R. Capital E X P R E S S I O N. Capital B A C K S L A S H. Capital S E Q U. Regular expression class. Capital R E G U L A R. Capital E X P R E S S I O N. Capital B A C K S L A S H. Capital S E Q U. Regular expression non-terminator. Regular expression non-terminator. Source character but not line terminator. Regular expression class. Regular expression class chars. Regular expression class chars. Empty. Regular expression class chars. Regular expression class char. Regular expression class char. Regular expression non-terminator but not one of or. Capital R E G U L A R. Capital E X P R E S S I O N. Capital B A C, K, S, L, A, S, H, capital S, E, Q, U. Note 1. A regular expression literal is an input element that is converted to a regexp object. See 22.2 each time the literal is evaluated. Two regular expression literals in a program evaluate two regular expression objects that never compare as equals to each other even if the two literals' contents are identical. A regexp object may also be created at runtime by new regexp or calling the regexp constructor as a function. C22.2.4. 34. ECMA International 2024. Regular expression flags. Empty. Regular expression flags identify part char 2, 9, 5, 1 static semantics. Body text. The syntax-directed operation body text takes no arguments and returns source text. It is defined piecewise over the following productions: regular expression literal, regular expression body, regular expression flags. Return the source text that was recognized as regular expression body 1, 2, 9, 5. To static semantics. Flag text. The syntax-directed operation flag text takes no arguments and returns source text. It is defined piecewise over the following productions: regular expression literal, regular expression body, regular expression flags. Return the source text that was recognized as regular expression flags 1, 2, 9, 6. Template literal lexical components. Syntax. Template. No substitution template. Template head. No substitution template. Template character sop. Template head. Template character sop. $. Template substitution tail. Template middle. Template tail. Template middle. Template character sop. $. Template tail. Template character sop. Template characters. Template character. Template character sopt. Note 2. Regular expression literals may not be empty. Instead of representing an empty regular expression literal, the code unit S equals starts a single line comment. To specify an empty regular expression, use Dart. ECMA International 2024 235. Template character. Look ahead. Template escape sequence. Not escape sequence. Line continuation. Line terminator sequence. Source character but not one of or $, or line terminator. Template escape sequence. Character escape sequence. Look ahead decimal digit. Hex escape sequence. Unicode escape sequence. Not escape sequence. 0 decimal digit but not 0. X. Look ahead hex digit. X hex digit. Look ahead hex digit. U. Look ahead hex digit. Look ahead. U hex digit. Look ahead hex digit. U hex digit hex digit. Look ahead hex digit. U hex digit hex digit hex digit. Look ahead hex digit. U. Look ahead hex digit. U. Not code point. Look ahead hex digit. U. Code point. Look ahead hex digit. Look ahead not code point. Hex digits. Sep. But only if MV of hex digits. 0 times 10 FF. Code point. Hex digits. Sep. But only if MV of hex digits 0 times 10 FF. Note template substitution tailors used by the input element template tail alternative lexical goal 1, 2, 9, 6. 1 static semantics. TV. The syntax-directed operation TV takes no arguments and returns a string or undefined. A template literal component is interpreted by TV as a value of the string type. TV is used to construct the index components of a template object, colloquially, the template values. In TV, escape sequences are replaced by the UTF-16 code units of the Unicode code point represented by the escape sequence. The TV of no substitution template is the empty string. The TV of template head, $, is the empty string. The TV of template middle, $, is the empty string. The TV of template tail is the empty string. The TV of template characters, template characters is undefined if the TV of template character is undefined or the TV of template characters is undefined. Otherwise, it is the string concatenation of the TV of template character and the TV of template characters. The TV of template character, source character but not one of or $, or line terminator is the result of performing UTF-16 encode code point on the code point matched by source character. The TV of template character $ is the string value consisting of the code unit 0 times 0024. $, the TV of template character, template escape sequences, the SV of template escape sequence, the TV of template character, not escape sequences undefined, the TV of template character, line terminator sequences, the TRV of line terminator sequence, 236. Copyright sign, ECMA International 2024, the TV of line continuation, line terminator sequences, the empty string 1, 2, 9, 6, to static semantics, TRV, the syntax-directed operation TRV takes no arguments and returns a string. A template literal component is interpreted by TRV as a value of the string type. TRV is used to construct the raw components of a template object, colloquially, the template raw values. TRV is similar to TV, with the difference being that in TRV, escape sequences are interpreted as they appear in the literal. The TRV of no substitution template is the empty string. The TRV of template head, $ is the empty string. The TRV of template middle, $ is the empty string. The TRV of template tail is the empty string. The TRV of template characters, template characters is the string concatenation of the TRV of template character and the TRV of template characters. The TRV of template character, source character but not one of or $, or line terminator is the result of performing UTF-16 encode code point on the code point matched by source character. The TRV of template character, $ is the string value consisting of the code unit 0 times 0024. $, the TRV of template character, template escape sequences, the string concatenation of the code unit 0 times 005C, reverse solidus, and the TRV of template escape sequence, the TRV of template character, not escape sequences, the string concatenation of the code unit 0 times 005C, reverse solidus, and the TRV of not escape sequence, the TRV of template escape sequence. 0 is the string value consisting of the code unit 0 times 0030, digit 0, the TRV of not escape sequence. 0 decimal digit is the string concatenation of the code unit 0 times 0030, digit 0, and the TRV of decimal digit, the TRV of not escape sequence. X, look ahead hex digit, is the string value consisting of the code unit 0 times 0078, Latin small letter x, the TRV of not escape sequence. X hex digit, look ahead hex digit, is the string concatenation of the code unit 0 times 0078, Latin small letter x, and the TRV of hex digit, the TRV of not escape sequence. U, look ahead hex digit, look ahead, is the string value consisting of the code unit 0 times 0075, Latin small letter u, the TRV of not escape sequence. U hex digit, look ahead hex digit, is the string concatenation of the code unit 0 times 0075, Latin small letter u, and the TRV of hex digit, the TRV of not escape sequence. U hex digit, look ahead hex digit, is the string concatenation of the code unit 0 times 0075, Latin small letter u, the TRV of the first hex digit, and the TRV of the second hex digit, the TRV of not escape sequence. U hex digit, look ahead hex digit, is the string concatenation of the code unit 0 times 0075, Latin small letter u, the TRV of the first hex digit, the TRV of the second hex digit, and the TRV of the third hex digit, the TRV of not escape sequence. U, look ahead hex digit, is the string concatenation of the code unit 0 times 0075, Latin small letter u, and the code unit 0 times 007b, left curly bracket, the TRV of not escape sequence. U, not code point, look ahead hex digit, is the string concatenation of the code unit 0 times 0075, Latin small letter u, the code unit 0 times 007b, left curly bracket, and the TRV of not code point, the TRV of not escape sequence. U, code point, look ahead hex digit, look ahead, is the string concatenation of the code unit 0 times 0075, Latin small letter u, the code unit 0 times 007b, left curly bracket, and the TRV of code point, the TRV of decimal digit, 1 of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 is the result of performing UTF-16 encode code point on the single code point matched by this production. The TRV of character escape sequence. Non-escape character is the SV of non-escape character. The TRV of single escape character, 1 of BFNRTV, is the result of performing UTF-16 encode code point on the single code point matched by this production. The TRV of hex escape sequence. Hex digit is the string concatenation of the code unit 0 times 0078, Latin small letter x, the TRV of the first hex digit, and the TRV of the second hex digit. The TRV of Unicode escape sequence. U hex 4 digits is the string concatenation of the code unit 0 times 0075, Latin small letter u, and the TRV of hex 4 digits. The TRV of Unicode escape sequence. U code point is the string concatenation of the code unit 0 times 0075, Latin small letter u, the code unit 0 times 007b, left curly bracket, the TRV of ECMA International 2024 237 code point, and the code unit 0 times 007d, right curly bracket, the TRV of hex 4 digits. Hex digit is the string concatenation of the TRV of the first hex digit, the TRV of the second hex digit, the TRV of the third hex digit, and the TRV of the fourth hex digit. The TRV of hex digits. Hex digit is the string concatenation of the TRV of hex digits and the TRV of hex digit. The TRV of hex digit. 1 of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 ABCDEF. ABCDEF is the result of performing UTF-16 encode code point on the single code point matched by this production. The TRV of line continuation. Line terminator sequences the string concatenation of the code unit 0 times 005C, reverse solidus, and the TRV of line terminator sequence. The TRV of line terminator sequence, LF, is the string value consisting of the code unit 0 times 000 line feed. The TRV of line terminator sequence, CR, is the string value consisting of the code unit 0 times 000 line feed. The TRV of line terminator sequence, LS, is the string value consisting of the code unit 0 times 2028 line separator. The TRV of line terminator sequence, PS, is the string value consisting of the code unit 0 times 2029 paragraph separator. The TRV of line terminator sequence, CRLF, is the string value consisting of the code unit 0 times 000 line feed. 2.10 automatic semicolon insertion. Most ECMAScript statements and declarations must be terminated with a semicolon. Such semicolons may always appear explicitly in the source text. For convenience, however, such semicolons may be omitted from the source text in certain situations. These situations are described by saying that semicolons are automatically inserted into the source code token stream in those situations. 2.10.1 Rules of automatic semicolon insertion. In the following rules, token means the actual recognized lexical token determined using the current lexical goal symbol as described in clause 12. There are 3 basic rules of semicolon insertion. When, as the source text is passed from left to right, a token, called the offending token, is encountered that is not allowed by any production of the grammar, then a semicolon is automatically inserted before the offending token if one or more of the following conditions is true. The offending token is separated from the previous token by at least one line terminator. The offending token is, the previous token is, and the inserted semicolon would then be passed as the terminating semicolon of a do-while statement 147.2. When, as the source text is passed from left to right, the end of the input stream of tokens is encountered, and the parser is unable to parse the input token stream as a single instance of the goal non-terminal, then a semicolon is automatically inserted at the end of the input stream. When, as the source text is passed from left to right, a token is encountered that is allowed by some production of the grammar, but the production is a restricted production and the token would be the first token for a terminal or non-terminal immediately following the annotation, no line terminator here, within the restricted production. And therefore such a token is called a restricted token, and the restricted token is separated from the previous token by at least one line terminator. Then a semicolon is automatically inserted before the restricted token. Note TV excludes the code units of line continuation while TRV includes them. CR, LF, and CR line terminator sequences are normalized to LF for both TV and TRV. An explicit template escape sequence is needed to include a CR or CR, LF sequence 38 ECMA International 2024. However, there is an additional overriding condition on the preceding rules. A semicolon is never inserted automatically if the semicolon would then be passed as an empty statement or if that semicolon would become one of the two semicolons in the header of a for statement C14.7. 4. Note the following are the only restricted productions in the grammar. Update expression, yield, await. Left-hand side expression yield await. No line terminator here, plus left-hand side expression yield await. No line terminator here. Continue statement, yield, await. Continue, continue. No line terminator here. Label identifier yield await. Break statement, yield, await. Break, break. No line terminator here. Label identifier yield await. Return statement, yield, await. Return, return. No line terminator here. Expression, plus and yield await. Throw statement, yield, await. Throw, no line terminator here. Expression, plus and yield await. Yield expression, in, await. Yield, yield. No line terminator here. Assignment expression in, plus yield await. Yield, no line at. Terminator here. Assignment expression in, plus yield await. Arrow function, in, yield, await. Arrow parameters yield await. No line terminator here, equals, concise body in, async function declaration, yield, await, default, async. No line terminator here, function binding identifier yield await. Formal parameters, yield, plus await, async function body, plus default, async. No line terminator here, function, formal parameters, yield, plus await, async function body, async function expression, async. No line terminator here, function binding identifier, yield, plus await opt, formal parameters, yield, plus await, async function body, async method, yield, await, async. No line terminator here, class element name yield await, unique formal parameters, yield, plus await, async function body, async generator declaration, yield, await, default, async. No line terminator here, function binding identifier yield await, formal parameters, plus yield, plus await, async generator body, plus default, async. No line terminator here, function, formal parameters, plus yield, plus await, async generator body, async generator expression, async. No line terminator here, function binding identifier, plus yield, plus await opt, formal parameters, plus yield, plus await, async generator body, async generator method, yield, await, async. No line terminator here, class element name yield await, unique formal parameters, plus yield, plus await, async generator body, async arrow function, in, yield, await, async. No line terminator here, async arrow binding identifier yield, no line terminator here, equals, async concise body in, capital C, O, V, E, R, capital C, A, L, L, capital E, X, P, R, E, S, S, I, O, N, capital A, N, D, capital A, S, Y, N, C, capital A, R, R, yield await. No line terminator here, equals, Async concise body in ECMA International 2024 239. Async arrowhead. Async. No line terminator here. Arrow formal parameters. Yield. Plus await. The practical effect of these restricted productions is as follows. When a plus plus or token is encountered where the parser would treat it as a postfix operator, and at least one line terminator occurred between the preceding token and the plus plus or token, then a semicolon is automatically inserted before the plus plus or token. When a continue, break, return, throw, or yield token is encountered and a line terminator is encountered before the next token, a semicolon is automatically inserted after the continue, break, return, throw, or yield token. When arrow function parameter s are followed by a line terminator before it equals token, a semicolon is automatically inserted and the punctuator causes a syntax error. When an async token is followed by a line terminator before a function or identifier name or token, a semicolon is automatically inserted and the async token is not treated as part of the same expression or class element as the following tokens. When an async token is followed by a line terminator before a token, a semicolon is automatically inserted and the punctuator causes a syntax error. The resulting practical advice to ECMAScript PROLOGUE is a postfix plus plus or operator should be on the same line as its operand. An expression in a return or throw statement or an assignment expression in a yield expression should start on the same line as the return, throw, or yield token. A label identifier in a break or continue statement should be on the same line as the break or continue token. The end of an arrow function's parameter s and its equals should be on the same line. The async token preceding an asynchronous function or method should be on the same line as the immediately following token. 2, 1, 0. Two examples of automatic semicolon insertion. This section is non-normative. The source, 12, 3, is not a valid sentence in the ECMAScript grammar, even with the automatic semicolon insertion rules. In contrast, the source, 1, 2, 3, is also not a valid ECMAScript sentence, but is transformed by automatic semicolon insertion into the following 1, 2, 3, which is a valid ECMAScript sentence. The source, 4, A, B, 40, copyright sign, ECMA International 2024, is not a valid ECMAScript sentence and is not altered by automatic semicolon insertion because the semicolon is needed for the header of a for statement. Automatic semicolon insertion never inserts one of the two semicolons in the header of a for statement. The source, return, a plus b, is transformed by automatic semicolon insertion into the following return, a plus b. The source, a equals b plus plus c, is transformed by automatic semicolon insertion into the following a equals b plus plus c. The source, if B else C equals D, is not a valid ECMAScript sentence and is not altered by automatic semicolon insertion before the else token, even though no production of the grammar applies at that point, because an automatically inserted semicolon would then be passed as an empty statement. is not a valid ECMAScript sentence and is not altered by automatic semicolon insertion before the else token, even though no production of the grammar applies at that point. Because an automatically inserted semicolon would then be passed as an empty statement. The source a equals b plus c d plus e print is not transformed by automatic semicolon insertion, because the parenthesized expression that begins the second line can be interpreted as an argument list for a function call a equals b plus c d plus e print. In the circumstance that an assignment statement must begin with a left parenthesis, it is a good idea for the programmer to provide an explicit semicolon at the end of the preceding statement rather than to rely on automatic semicolon insertion. 2.1.0. 3 interesting cases of automatic semicolon insertion. This section is non-normative. Note 1. The expression a plus b is not treated as a value to be returned by the return statement, because a line terminator separates it from the token return. Note 2. The token plus plus is not treated as a postfix operator applying to the variable b, because a line terminator occurs between b and plus plus. ECMA International 2024-241. ECMAScript programs can be written in a style with very few semicolons by relying on automatic semicolon insertion. As described above, semicolons are not inserted at every new line, and automatic semicolon insertion can depend on multiple tokens across line terminators. As new syntactic features are added to ECMAScript, additional grammar productions could be added that cause lines relying on automatic semicolon insertion preceding them to change grammar productions when parsed. For the purposes of this section, a case of automatic semicolon insertion is considered interesting if it is a place where a semicolon may or may not be inserted, depending on the source text which precedes it. The rest of this section describes a number of interesting cases of automatic semicolon insertion in this version of ECMAScript. 2.1.0. 3. 1 interesting cases of automatic semicolon insertion in statement lists. In a statement list, many statement list items end in semicolons, which may be omitted using automatic semicolon insertion. As a consequence of the rules above, at the end of a line ending an expression, a semicolon is required if the following line begins with any of the following: an opening parenthesis. Without a semicolon, the two lines together are treated as a call expression, an opening square bracket. Without a semicolon, the two lines together are treated as property, access, rather than an array literal or array assignment pattern, a template literal. Without a semicolon, the two lines together are interpreted as a tag template. The 13th of March 2011, with the previous expression as the member expression, an array plus or. Without a semicolon, the two lines together are interpreted as a usage of the corresponding binary operator, a regexp literal. Without a semicolon, the two lines together may be parsed instead as the multiplicative operator. For example, if the regexp has flags 2.1.0. 3. 2 cases of automatic semicolon insertion and no line terminator here. This section is non-normative. ECMAScript contains grammar productions which include no line terminator here. These productions are sometimes a means to have optional operands in the grammar. Introducing a line terminator in these locations would change the grammar production of a source text by using the grammar production without the optional operand. The rest of this section describes a number of productions using no line terminator here in this version of ECMAScript. 2.1.0. 3. 2. 1 list of grammar productions with optional operands and no line terminator here. Update expression, continue statement, break statement, return statement, yield expression, async function definitions, 15.8, with relation to function definitions, 15.2. 42. ECMA International 2024, 13 ECMAScript language. Expressions. 3.1 Identifier syntax, identifier reference, yield, await, identifier, yield, yield, await, await, binding identifier, yield, await, identifier, yield, await, label identifier, yield, await, identifier, yield, yield, await, await, identifier, identifier name but not reserved word. 3. 1. 1 static semantics, early errors, binding identifier, Identifier. It is a syntax error if the source text match by this production is contained in strict mode code and the string value of identifier is either arguments or eval. Identifier reference. Yield binding identifier. Yield label identifier. Yield. It is a syntax error if the source text match by this production is contained in strict mode code. Identifier reference. Await binding identifier. Await label identifier. Await. It is a syntax error if the goal symbol of the syntactic grammar is module. Binding identifier. Yield. Await. Yield. It is a syntax error if this production has a yield parameter. Binding identifier. Yield. Await. Await. ECMA International 2024 243. Yield and await are permitted as binding identifier in the grammar and prohibited with static. Note, semantics below. To prohibit automatic semicolon insertion in cases such as let await 0, it is a syntax error if this production has an await parameter. Identifier reference. Yield. Await. Identifier binding identifier. Yield. Await. Identifier label identifier. Yield. Await. Identifier. It is a syntax error if this production has a yield parameter and string value of identifier as yield. It is a syntax error if this production has an await parameter and string value of identifier as await. Identifier. Identifier name but not reserved word. It is a syntax error if this phrase is contained in strict mode code and the string value of identifier name is one of implements, interface, let, package, private, protected, public, static, or yield. It is a syntax error if the goal symbol of the syntactic grammar is module and the string value of identifier name is await. It is a syntax error if the string value of identifier name is the string value of any reserved word except for yield or await. 3. 1. 2. Static semantics. String value. The syntax-directed operation string value takes no arguments and returns a string. It is defined piecewise over the following productions: identifier name, identifier start, identifier name, identifier part. Let id text unescape be identifier code points of identifier name, return code points to string. Id text unescaped. Identifier reference. Yield binding identifier. Yield label identifier. Yield. Return yield. Identifier reference. Await binding identifier. Await label identifier. Await. Return await. Identifier. Identifier name but not reserved word. Return the string value of identifier name. Private identifier. Identifier name. Return the string concatenation of 0 times 0023. Number sign. And the string value of identifier name. Module export name. String literal 1. Return the SV of string literal. Note string value of identifier name normalizes any Unicode escape sequences in identifier name, hence such escapes cannot be used to write an identifier whose code point sequence is the same as a reserved word. 44. ECMA International 2024 131. 3. Runtime semantics. Evaluation. Identifier reference. Identifier. Return. Resolve binding. String value of identifier. Identifier reference. Yield. Return. Resolve binding. Yield. Identifier reference. Await. Return. Resolve binding. Await. Note 1. The result of evaluating an identifier reference is always a value of type reference. 3.2. Primary expression syntax. Primary expression. Yield. Await. This identifier reference yield await. Literal. Array literal yield await. Object literal yield await. Function expression. Class expression yield await. Generator expression. Async function expression. Async generator expression. Regular expression literal. Template literal yield await. Tagged. Capital C O V E R. Capital P A R E N T H E S I Z E D. Capital E X P R E S S I O N. Capital A N. Yield await. Capital C O V E R. Capital P A R E N T H E S I Z E D. Capital E X P R capital A, N, yield, await, expression, plus in yield await, expression, plus in yield await, dot, binding identifier yield await, dot, binding pattern yield await, expression, plus in yield await, binding identifier yield await, expression, plus in yield await, binding pattern yield await. Note 2 in non-strict code. The keyword yield may be used as an identifier. Evaluating the identifier reference resolves the binding of yield as if it was an identifier. Early error restriction ensures that such an evaluation only can occur for non-strict code. ECMA International 2024 245. Supplemental syntax. When processing an instance of the production, primary expression, yield, await, capital C, O, V, E, R, capital P, A, R, E, N, T, H, E, S, I, Z, E, D, capital E, X, P, R, E, S, S, I, O, N, capital A, N, yield await. The interpretation of cover parenthesized, capital E, X, P, R, E, S, S, I, O, N, capital A, N, D, capital A, R, R, O, W, capital P, A, R, A, M, E, T, E, R, capital L, I, S, is refined using the following grammar. Parenthesized expression, yield, await, expression, plus in yield await. 3, 2, 1 ethis keyword. 3, 2, 1. 1 runtime semantics. Evaluation. Primary expression. This. Return. Resolve this binding. 3, 2. 2 identifier reference. C13.1 for identifier reference 1 3, 2. 3 literals. Syntax. Literal. Null literal. Boolean literal. Numeric literal. String literal. 3, 2, 3. 1 runtime semantics. Evaluation. Literal. Null literal 1. Return null. Literal. Boolean literal. If Boolean literal is the token false, return false. If Boolean literal is the token true, return true. Literal. Numeric literal. Return the numeric value of numeric literal as defined in 1 2, 9, 3. Literal. String literal. Return the SV of string literal as defined in 1 2, 9, 4, 2. 46. ECMA International 2024 1 3, 2. 4 array initializer. Array elements may be elided at the beginning, middle, or end of the element list. Whenever a comma in the element list is not preceded by an assignment expression, that is, a comma at the beginning or after another comma, the missing array element contributes to the length of the array and increases the index of subsequent elements. Elided array elements are not defined. If an element is elided at the end of an array, that element does not contribute to the length of the array. Syntax. Array literal. Yield. Await. Elision ort. Element list yield await. Element list yield await. Elision ort. Element list. Yield. Await. Elision ort assignment expression. Plus in yield await. Elision ort spread element yield await. Element list yield await. Elision ort assignment expression. Plus in yield await. Element list yield await. Elision ort spread element yield await. Elision. Spread element. Yield. Await. Dot. Assignment expression. Plus in yield await. 1 3, 2, 4. 1 runtime semantics. Array accumulation. The syntax-directed operation array accumulation takes arguments array, an array, and next int x, an integer, and returns either a normal completion containing an integer or an abrupt completion. It is defined piecewise over the following productions. Elision. Let len be next index plus 1. Perform. Set. Array. Length. Len. True. Note. The above step throws if len exceeds 232 1. Return len. Elision. Return. Array accumulation of elision with arguments array and next index plus 1. Element list. Elision ort assignment expression. If elision is present, then a set next index 2. Array accumulation of elision with arguments array and next index. Let init result be Evaluation of assignment expression. Let init value be. Get value. Init result. Perform. Create data property or throw. Array. To string. Next int x. Init value. Return next index plus 1. Note an array literal is an expression describing the initialization of an array using a list of 0 or more expressions, each of which represents an array element t enclosed in square brackets. The elements need not be literals. They are evaluated each time the array initializer is evaluated. ECMA International 2024 247. Element list. Elision spread element. If elision is present, then a set next index 2. Array accumulation of elision with arguments array and next index. Return. Array accumulation of spread element with arguments array and next index. Element list. Element list. Elision assignment expression. Set next index 2. Array accumulation of element list with arguments array and next index. If elision is present, then a set next index 2. Array accumulation of elision with arguments array and next index. Let init result be. Evaluation of assignment expression. Let init value be. Get value. Init result. Perform. Create data property or throw. Array. To string. Next int x. Init value. Return next index plus 1. Element list. Element list. Elision spread element. Set next index 2. Array accumulation of element list with arguments array and next index. If elision is present, then a set next index 2. Array accumulation of elision with arguments array and next index 3. Return. Array accumulation of spread element with arguments array and next index. Spread element. Assignment expression. Let spread ref be. Evaluation of assignment expression. Let spread obj be. Get value. Spread ref. Let iterator record be. Get iterator. Spread obj. Sync. Repeat. Let next be. Iterator step value. Iterator record. B if next is done. Return next index. C perform. Create data property or throw. Array. To string. Next int x. Next. D set next index to next index plus 1. Note create data property or throw is used to ensure that own properties are defined for the array, even if the standard built-in array prototype object has been modified in a manner that would preclude the creation of new own properties using 3, 2, 4, 2. Runtime semantics. Evaluation. Array literal. Elision let array be. Array create 0 if elision is present, then a perform. Array accumulation of elision with arguments array and 0, 3. Return array. Array literal. Element list. Let array be. Array create 0. Perform. Array accumulation of element list with arguments array and 0. Return array. Array literal. Element list. Elision 2. Let array be. Array create 0. Let next index be. Array accumulation of element list with arguments array and 0. 48. ECMA International 2024. 3. If elision is present, then a perform. Array accumulation of elision with arguments array and next index. Return array. 3, 2, 5. Object initializer. Syntax. Object literal. Yield. Await. Property definition list. Yield await. Property definition list. Yield await. Property definition list. Yield. Await. Property definition yield await. Property definition list. Yield await. Property definition yield await. Property definition. Yield. Await. Identifier. Reference yield await. Cover initialize name yield await. Property name yield await. Assignment expression. Plus in yield await. Method definition yield await. Dart. Assignment expression. Plus in yield await. Property name. Yield. Await. Literal property name. Computed property name yield await. Literal property name. Identifier name. String literal numeric literal. Computed property name. Yield. Await. Assignment expression. Plus in yield await. Cover initialized name. Yield. Await. Identifier reference yield await. Initializer. Plus in yield await. Initializer. In. Yield. Await. Assignment expression in yield await. Note 2 method definition is defined in 15.4. Note 1 an object initializer is an expression describing the initialization of an object, written in a form resembling a literal. It is a list of 0 or more pairs of property keys and associated values, enclosed in curly brackets. The values need not be literals. They are evaluated each time the object initializer is evaluated. Copyright sign. ECMA International 2024 249. Note 3. In certain contexts, object literal is used as a cover grammar for a more restricted secondary grammar. The cover initialized name production is necessary to fully cover these secondary grammars. However, use of this production results in an early syntax error in normal contexts where an actual object literal is expected. 3, 2, 5, 1 Static semantics. Early errors. Property definition. Method definition. Bullet. It is a syntax error if his direct super of method definition is true. It is a syntax error if private bound identifiers of method definition is not empty. In. Used as a cover grammar for object assignment pattern and may be recognized as part of a capital C O V E R capital P A R E N T H E S I Z E D capital E X P R E S S I O N capital A N. When object literal appears in a context where object assignment pattern is required, the following early error rules are not applied. In addition, they are not applied when initially parsing the capital C O V E R capital P A R E N T H E S I Z E D capital E X P R E S S I O N capital A N or capital C O V E R capital C A L L capital E X P R E S S I O N capital A N D capital A S Y N C capital A R R. Property definition. Cover initialized name. It is a syntax error if any source text is matched by this production. Object literal. Property definition list. Property definition list. It is a syntax error if property name list of property definition list contains any duplicate entries for proto and at least 2 of those entries were obtained from productions of the form. Property definition. Property name. Assignment expression. This rule is not applied if this object literal is contained within a script that is being parsed for JSON parse. See step 4 of JSON parse. 3, 2, 5. To static semantics is computed property key. The syntax directed operation is computed property key takes no arguments and returns a boolean. It is defined piecewise over the following productions. Property name, literal property name, return false, property name, computed property name, return true. Addition to describing an actual object initialize are the object literal productions are also 250. ECMA International 2024. Note 1. This production exists so that object literal can serve as a cover grammar for object assignment pattern. It cannot occur in an actual object initializer. Note 2. The list returned by property name list does not include property names defined using a computed property name. 1, 3, 2, 5, 3 Static semantics. Property name list. The syntax directed operation property name list takes no arguments and returns a list of strings. It is defined piecewise over the following productions. Property definition list. Property definition. Let prop name be prop name of property definition. If prop name is empty, return a new empty list. Return prop name. Property definition list. Property definition list. Property definition. Let list be property name list of property definition list. Let prop name be prop name of property definition. If prop name is empty, return list. Return the list concatenation of list and prop name. 3, 2, 5. For runtime semantics. Evaluation. Object literal. Return ordinary. Object create. Object prototype. Object literal. Property definition list. Property definition list. Let obj be ordinary. Object create. Object prototype. Perform. Property definition evaluation of property definition list with argument obj. Return obj. Literal property name. Identifier name. Return string value of identifier name. Literal property name. String literal 1. Return the SV of string literal. Literal property name. Numeric literal. Let NBR be the numeric value of numeric literal. Return to string. NBR. Computed property name. Assignment expression. Let exp value be. Evaluation of assignment expression. Let prop name be. Get value. Exp value. Return to property key. Prop name. 3, 2, 5. 5 runtime semantics. Property definition evaluation. The syntax.
There was 2093, 93 matches. Now there is down, it's too low.
Property definition list. Property definition. Perform. Property evaluation of property definition list with argument object. Perform. Evaluation of property definition with argument object. Return unused. ECMA International 2024 251. Property definition. Assignment expression. Let exp value be. Evaluation of assignment expression. Let from value be. Get value. Exp value. Let excluded names be a new empty list. Perform. Copy data properties. Object. From value. Excluded names. Return unused. Property definition. Identifier reference. Let prop name be string value of identifier reference. Let exp value be. Evaluation of identifier reference. Let prop value be. Get value. Exp value. Assert. Object is an ordinary, extensible object with no
So I replaced 1095 ints to the new type, whatever.
Value. Return.
I still have to do JavaScript files. I'm doing those not now. I'm considering this done. Well, this part, whatever. I found
Then a let is proto set to be false. Else if prop key is proto and
a couple of these. So that'll be fun when for now I'm good. I found a couple other tiny things I have to technically also rename to some common type name so it'll be able to expand to 64-bit. This takes so long. So I'm gonna try to run it. I could possibly have messed up. If I didn't, it'll run. So I'm gonna see if it runs.
Pro. Object. Prop key. Prop value. 0. Return unused. Property definition. Method definition. Perform. Method definition evaluation of method definition with arguments. Object.
Clean the solution.
3, 2.
Make it clean. And it says it clean. Now build.
Generator expression. See 15.7 for primary.
You have to clean the solution in Visual Studio because it's a poopy compiler, and you gotta click clean to clean up the poop because this compiler it just poops all over, and even clicking clean it doesn't get all the poop. I won't get into it. I'll complain another time. So build. Could this just work for once? Build. Build. I need some water. Rebuild here. Really hoping this is gonna work on the first try.
I-O-N capital L-I.
I'm gonna go walk away. This will take 2 minutes. I'll be back. I'm hoping it's gonna build. I don't wanna anticipation. I'll be back. Whatever.
A-L-I-D capital R E G U L A R, capital E X P R E S S I O N, capital L I T E R A, literal. The abstract operation, capital I S, capital V A L I D, capital R E G U L A R, capital E X P R E S S I O N, capital L I T E R A, takes argument literal, a regular expression literal parse node, and returns a boolean. It determines if its argument is a valid regular expression literal. It performs the following steps when called. Let flags be flag text of literal if flags contains any code points other than D, G, I, M, S, U, V, or Y, or if flags contains any code point more than once. Return false. If flags contains U, let U be true, else let U be false. If flags contains V, let V be true, else let V be false. Let pattern text be body text of literal if U is false and V is false. Then, let string value be code points to string pattern text. B set pattern text to the sequence of code points resulting from interpreting each of the 16-bit elements of string value as a Unicode BMP code point. UTF-16 decoding is not applied to the elements. Let parse result be parse pattern text U V. If parse result is a parse node, return true, else return false. 3, 2, 7, 3 run. Time semantics. Evaluation primary expression, regular expression literal. Let pattern be code points to string, body text of regular expression literal. Let flags be code points to string, flag text of regular expression literal. Return regexp create pattern flags. 3, 2, 8 template literals syntax. Template literal yield await tagged. No substitution template. Substitution template yield await tagged. Substitution template yield await tagged. Template head expression plus in yield await. Template spans yield await tagged. Template spans yield await tagged. Template tail. Template middle list yield await tagged. Template tail. ECMA International 2024 253. Template middle list yield await tagged. Template middle expression plus in yield await. Template middle list yield await tagged. Template middle expression plus in yield await. 3, 2, 8, 1 static semantics. Early errors. Template literal yield.
It builds. Alright. I'll check it tomorrow. Remember, when life gives you potatoes, make potato aid. Or I'm gonna let this stream run on for like 10 more minutes because the stream doesn't always end, so if I let it run for 10 minutes, it might end and send the end of what wouldn't be sent that should be sent but isn't sent all the time. So I'm letting it run on for 10 more minutes, so hoping it sends the whole stream. Peace. Or not.
Await tagged. Template tail. It is a syntax error if the tagged parameter was not set and template tail contains not escape sequence.
Oh, and hydrate.
Tagged
Water, it's whatever.
template middle list yield await tagged. Template middle.
Or don't. Do whatever, I don't care. Don't let me tell you what to do.
Was not set and template middle contains not escape sequence. 3, 2, 8. Just
Or do. I don't know. It's up to you. Oh, I need some water.
boolean and returns a list of either strings or undefined. It is defined piecewise over the following productions. Template literal, no substitution template. Return template string, no substitution template. Raw. Substitution template, template head expression template spans. Let head be template string, template head, raw. Let tail be template strings of template spans with argument draw. Return the list concatenation of head and tail. Template spans, template tail. Return template string, template tail, raw. Template spans, template middle list template tail. Let middle be template strings of template middle list with argument draw. Let tail be template string, template tail, raw. Return the list concatenation of middle and tail. 54. ECMA International 2024. Template middle list, template middle expression 1. Return template string, template middle, raw. Template middle list, template middle list template middle expression. Let front be template strings of template middle list with argument draw. Let last be template string, template middle, raw. Return the list concatenation of front and last. 3, 2, 8, 3 static semantics, template string, template token, raw. The abstract operation template string takes arguments template token, a no substitution template parse node, a template head parse node, a template middle parse node, or a template tail parse node, and raw, a boolean, and returns a string or undefined. It performs the following steps when called. If raw is true, then a let string be the TRV of template token, else a let string be the TV of template token. Return string. 3, 2, 8, 4 get template object, template literal. The abstract operation get template object takes argument template literal, a parse node, and returns an array. It performs the following steps when called. Let realm be the current realm record. Let template registry be realm. For each element of template registry, do if E is the same parse node as template literal, then I return E. Let raw strings be template strings of template literal with argument true. Assert raw strings is a list of strings. Let cook strings be template strings of template literal with argument false. Let count be the number of elements in the list cook strings. Assert count 232 1. Let template be array create count 0. Let raw obj be array create count 1. Let index be 0, 2. Repeat. While index count a let prop be to string index b let cooked value be cook strings index c perform. Define property or throw template prop property descriptor cooked value writable false true false. D let raw value be the string value raw strings index e perform. Define property or throw raw obj prop property descriptor raw value false true false. F set index to index plus 1 3 perform. Set integrity level raw obj frozen 4 perform. Define property or throw template raw property descriptor raw obj false enumerable false false 5 perform. Set integrity level template frozen 6 append the record template literal template to realm 7 return template. Note this operation returns undefined if raw is false and template token contains a not escape sequence. In all other cases, it returns a string. ECMA International 2024 255. Note 1. The creation of a template object cannot result in an abrupt completion. Note 2. Each template literal in the program code of a realm is associated with a unique template object that is used in the evaluation of tagged templates. 1 3 2 8 6. The template object TS are frozen in the same template object is used each time a specific tag template is evaluated. Whether template objects are created lazily upon first evaluation of the template literal or eagerly prior to first evaluation is an implementation choice that is not observable to ECMAScript code. 1 3 2 8 5 Runtime semantics. Substitution evaluation. The syntax-directed operation substitution evaluation takes no arguments and returns either a normal completion containing a list of ECMAScript language values or an abrupt completion. It is defined piecewise over the following productions. Template spans. Template tail. Return a new empty list. Template spans. Template middle list. Template tail. Return. Substitution evaluation of template middle list. Template middle list. template middle expression, let subref b. Evaluation of expression, let sub b. Get value, subref, return sub, template middle list, template middle expression, let preceding b. Substitution evaluation of template middle list, let next ref b. Evaluation of expression, let next b. Get value, next ref, return the list concatenation of preceding and next. 3, 2, 8, 6 runtime semantics. Evaluation, template literal, no substitution template. Return the TV of no substitution template as defined in 1, 2, 9, 6. Substitution template. Template head expression template spans. Let head be the TV of template head as defined in 1, 2, 9, 6. Let subref be. Evaluation of expression. Let sub be. Get value. Subref. Let middle be. To string. Sub. Let tail be. Evaluation of template spans. Return the string concatenation of head, middle, and tail. 56. ECMA International 2024. Note 3 future editions of this specification may define additional non-enumerable properties of template objects. Note 1 the string conversion semantics applied to the expression value like string prototype concat rather than the plus operator. Template spans. Template tail. Return the TV of template tail as defined in 1, 2, 9, 6. Template spans. Template middle list template tail. Let head be. Evaluation of template middle list. Let tail be the TV of template tail as defined in 1, 2, 9, 6. Return the string concatenation of head and tail. Template middle list. Template middle expression. Let head be the TV of template middle as defined in 1, 2, 9, 6. Let subref be. Evaluation of expression. Let sub be. Get value. Subref. Let middle be. To string. Sub. Return the string concatenation of head and middle. Template middle list. Template middle expression. Let rest be. Evaluation of template middle list. Let middle be the TV of template middle as defined in 1, 2, 9, 6. Let subref be. Evaluation of expression. Let sub be. Get value. Subref. Let last be. To string. Sub. Return the string concatenation of rest, middle, and last. 3, 2, 9 the grouping operator. 3, 2, 9. 1 static semantics. Early errors. Primary expression. Capital C, O, V, E, R. Capital P, A, R, E, N, T, H, E, S, I, Z, E, D, capital E, X, P, R, E, S, S, I, O, N, capital A, N, capital C, O, V, E, R, capital P, A, R, E, N, T, H, E, S, I, Z, E, D, capital E, X, P, R, E, S, S, I, O, N, capital A, N, must cover a parenthesized expression. 3, 2, 9. 2 runtime semantics. Evaluation. Primary expression. Capital C, O, V, E, R, capital P, A, R, E, N, T, H, E, S, I, Z, E, D, capital E, X, P, R, E, S, S, I, O, N, capital A, N. Let expa be the parenthesized